All right, we should probably get started. Wonderful. I'm very pleased to welcome you here today to the Academic Symposium on Climate and Global Change. My name is Robert Johnston, Director of the George Perkins Marsh Institute here at Clark. I'd like to take a few moments to introduce the symposium and introduce our speakers as well, and then we'll launch right into it. So why are we here today? Climate and global environmental change is arguably the most fundamental challenge of our time. Growing climate and environmental hazards threaten the well-being of every human on the planet, along with the natural systems upon which we all depend. For decades, Clark University has confronted the global climate crisis through research and engagement around the world. The tools, techniques, and information developed by Clark University researchers are shaping responses to climate and global change worldwide, with a guiding focus on engaged science to support human decisions and livelihoods. This panel introduces some of the work being done by Clark University on climate impacts, vulnerability, adaptation, and mitigation. Today, we've brought together 4 internationally recognized experts with a common focus on research to inform action, to give you a little taste of some of the work we're doing here at Clark. Before we begin, I'd like to briefly introduce the panel. First, Professor Ed Carr is Director of the International Development, Community, and Environment Department. Ed's research is marked by deep engagement with the institutions and practices of global development and climate change adaptation. He founded and directs the Humanitarian Response and Development Lab, Hurdle, here at Clark. He's also served as a lead author of several global environmental assessments, most recently the 6th Assessment Report of the Intergovernmental Panel on Climate Change, or IPCC. Rinku Roy Chowdhury is professor in the Graduate School of Geography. Her research is interdisciplinary and focuses on human-environment interactions in land systems in diverse geographical locations across the globe. She's very active in the U.S. Long-Term Ecological Research, or LTER, network, and she's co-chaired the Global Land Program of Future Earth and was a coordinating lead author in the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, also known as IPBES, and their global assessment launched at UNESCO Paris in 2019. Chris Williams is Professor of Earth System Science, also in the Graduate School of Geography, and Director of the Environmental Sciences Program here at Clark. His expertise is in terrestrial ecosystems, global environmental change, and climate change, focusing on foundational research science on the climate impact of forests. His team of researchers is developing action-ready data and tools to provide to decision makers around the world, including such organizations as the Nature Conservancy, the Open Space Institute, the Trust for Public Lands, and multiple U.S. states participating in the U.S. Climate Alliance. And finally, I'm Robert Johnston, Director of the George Perkins Marsh Institute and Professor of Economics at Clark. I'm an environmental economist studying the benefits and costs of environmental change and how humans make decisions with regard to the environment. Among various other roles, I'm currently on the steering committee of the Narragansett Bay Estuary Program, past chair of the Ecosystem Science and Management Working Group of the NOAA Science Advisory Board, and past member of the US EPA Science Advisory Board. I'm also currently editor of the journal Resource and Energy Economics. So that completes our introduction. We'll now begin with 4 brief presentations by each of our panelists, and then with the time remaining, we'll open up the floor to discussions about how Clark can best move forward in the area of climate and global change. So with that, I'd like to introduce our first speaker, Ed Carr.
Thanks, Rob. So, why worry about climate change adaptation and making it more effective? One of the things that we know is since the industrial era started, we've seen 1.1 degrees Celsius of global warming. The result of that has been impacts on people and nature that have been significant, observed impacts. This is not stuff we project, it's stuff that's already happened, that's challenging people's well-being around the world. As we move toward 1.5 degrees of warming, a temperature we're very likely to hit sometime around 2040, we expect that we will see severe impacts increasing. And as we pass 1.5 degrees, those will become even more intense and potentially irreversible. For example, crossing above 1.5 degrees and then pulling ourselves back down later in the century, while a positive move, still could result in things like extinctions, which are not reversible even if you bring temperatures back down in the long run. What this all means is that we are going to have to change the way we live in the world to deal with these impacts. But changing how we live in the world, adapting to these kinds of impacts is not straightforward. It's not simple. There are an awful lot of ways to get this wrong. For example, we could take actions that preserve problematic social structures, things that, say, disempower women and women's opportunities, and as a result, we could compromise long-term development opportunities in different parts of the world. We could implement interventions that make it very hard to mitigate climate change, to reduce the amount of greenhouse gas that we're emitting, thus working against ourselves in these sorts of efforts. Or we could bring to bear adaptation efforts that convince people that all we need to do is keep taking small incremental steps and somehow we'll deal with this, obscuring the fact that really we're looking down the barrel of transformational changes to deal with this. So there's a lot of ways to get this wrong, and what I spend a lot of my time doing is thinking about how to get it right. And I want to talk about that in three big arenas, three roles that I see in my job when I'm addressing this kind of issue. One of them relates to basic research, one of them relates to how we shape policy, and the last one about how we improve program and policy intervention. So, on the research front, my research story probably sounds a lot like most faculty's research story, in that I started on this road because I had interesting research questions about how people were dealing with economic and environmental change that was shaping their lives. I principally started this work in West Africa, in Ghana, and after a few years had an opportunity to take up a project in Malawi with other colleagues, and then Mali, and then eventually Senegal, then Zambia after that, and then finally Uganda. And as my career kind of kept going, as it kept adding countries, the team I was working with got larger and larger, and the amount of data we had in front of us got larger and larger. Today, we have a database of over 1,000 ethnographic interviews, literally years of observational data on how people in different parts of sub-Saharan Africa have been dealing with economic and environmental change. And as you can imagine, across that time, myself and my folks in my lab are also producing a lot of findings. For example, findings that point to the importance of social difference in effective adaptation, how gender roles, for example, really matter in terms of how well your projects work, how important local knowledge is, because of course that shapes how people take in adaptation opportunities. So we did that in terms of getting weather and climate information to people. But along with those smaller, more focused findings are meta findings that come when you've been working on something for 25 years and have this kind of a database. Like the fact that across all of the contexts that I've been working, one big thing we've seen is that when you reduce people's vulnerability overall to the impacts of climate change, opportunities emerge, especially among marginal and vulnerable populations, to actually implement transformational changes of their own in their own lives, to catalyze the kinds of transformational adaptation we need to see going forward. Now, this is all well and good. I actually love this work. I want to keep continuing doing it. However, it's one thing to do research, it's another thing to actually make it effective in the world. If all you're doing is research and then publishing it in journals, you're effectively throwing it over a wall and hoping that someone's reading it and implementing it. If you're counting on that, it's not working out. So what you have to do is argue for it in policy arenas. One of the arenas in which I've engaged in this is in global environmental assessments. As Rob mentioned, I was a lead author of the most recent IPCC report, the section on impacts, adaptation, and vulnerability. And I was a lead author of the last chapter in that report, and the job there was to synthesize everything that the rest of the report had talked about in terms of adaptation, make sense out of it in terms of where we might go to effectively adapt in a way that fostered productive mitigation and the achievement of development goals. As one of those lead authors, I was able to bring in 25 years of experience in research, as well as all the research that had influenced me, all the people I'd read and worked with over time, to bring that into that chapter and actually shape its outcome. Now, why does that matter for policy? Because the IPCC reports are the scientific foundation for the climate change negotiations you hear about all the time around the world. 193 countries actually have to agree to what's in the IPCC report, because that is the negotiating baseline now for the next 7 years. So that's one way in which you can pull your research into a policy arena and then actually shape an entire policy conversation at a global scale, potentially for the next 7 or 8 years. So that's great. Maybe we've got this into the policy arena. But getting things into the policy arena is not the same thing as doing things on the ground and in the world. And so that last thing is to think about how to get policy into implementation. And that then speaks to my third role here. I sit on the scientific and technical advisory panel to the Global Environment Facility. The Global Environment Facility is the funding mechanism for all of the large multilateral environmental agreements. So the Convention on Biodiversity, the Convention on Climate Change. When they're funding projects in the world, they are moving this money through the Global Environment Facility. My job on the panel is I'm the panel member for climate change adaptation. My job is to vet projects for scientific and technical merit, and to bring the latest thinking on adaptation to the overall work of the GEF. One of the things I've run into over the last 2 years reviewing projects are two interesting problems. One, projects that lacked an adaptation rationale. In other words, it wasn't really clear why they were adaptation. They were asking for adaptation money, but they weren't clearly defining an adaptation problem. The second were a lot of really good projects that were defining adaptation really kind of as preserving what is. And I just mentioned a few minutes ago, you could preserve a really unequal social situation. You could preserve people's perceptions about how they live in the world and really cause significant problems. To address this, I've actually built a tool that the GEF will start implementing in June, which is a decision support tool that helps people design better projects. It's just a decision tree. And all it does is walk people through a series of questions, all the consultants and implementers who build these projects, to guide them into the most effective thinking on adaptation and therefore the most effective projects. And that includes a section that gets at something as basic as, has there been an actual change in the climate? And if you think I needed to ask that, like I tell people all the time, it's why we have laws, because somebody did it. Same problem here. But also getting into more nuanced issues, right? In the name of screening for adaptation need or demand, looking at the differences that people have in terms of their experiences of climate change and why some people feel a need for an adaptation project or not. And getting into why people are actually adapting and how they're adapting gets us into local knowledge and into indigenous knowledge and the importance of that kind of work. And then finally, a step that says, how does all of this connect to other kinds of goals you're trying to achieve? Mitigation, development, biodiversity, et cetera. So the broader answer then is, how do you make climate change adaptation more effective? Through this process I described to you, starting with research, working on policy, moving that into implementation, and then doing it again, iterating, learning from all those things to reinform your questions. That to me is the heart of climate action, and that's one of the most exciting things about the work I get to do here at Clark. Thanks.
Thank you very much. Always a pleasure to go after you, Ed. So I'm going to start a timer. So again, it's a pleasure to be with you here today. And I am going to be a little bit of the odd one out in this panel in that I'm going to talk primarily about a different kind of global environmental change, not climate change, although these things are, of course, completely intertwined. So specifically, I'm going to talk about changes to global land use and land cover, which the recent global assessment of IPBES that Rob mentioned, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, that's a mouthful, and we have actually commonly come to the pronunciation of IPBES, more phonetic. So IPBES has unequivocally found through the work of hundreds of scientists over several years in this global assessment that global declines of biodiversity are driven most significantly by changes to land and sea use, followed closely by changes to the climate, right? So, and again, of course, these things are not independent of one another. So this phenomenon, of course, has extremely significant implications for human societies and natural systems alike. And I want to really point out that Clark University has been at the forefront of global land use and land cover change research, and indeed founded the initial scientific networks internationally that actually took up this mantle, starting with the Red Book, that many of us affectionately call this, the Earth Transformed by Human Action, which was authored by and organized into a poster workshop by several Clark faculty associated with the Marsh Institute and with the Graduate School of Geography, and of course other institutions. So that work led to the foundation of the Land Use Land Cover Change Program, which was an international science program, the first ever joint project of the International Geosphere Biosphere Program, the IGBP, and the International Human Dimensions Program, the IHDP. LUC then transformed over the years into what is now the Global Land Program. This is an institution that I've had the pleasure of co-chairing for a number of years and continue to serve on its scientific steering committee. So recently, a group of us from the scientific steering committee of the GLP authored this high-level perspective piece that actually summarizes decades of research on global land use, land cover change, kind of presenting 10 facts, alternatively 10 myths about land. And I'm not going to go over all of the 10, but I want to highlight a couple of them as points of departure for the rest of my presentation. So first is this assumption that there is land to spare for nature conservation, right? And I say this semi-facetiously, but point out that 3/4 of the globe's ice-free land is already under direct use, and the remainder actually generates indirect benefits for all kinds of human societies and sectors. Those benefits, however, are fundamentally unequally distributed. So, for example, about 65% of the world's kind of natural ecosystems or natural protected areas are really places where indigenous and local people live and work and carve out livelihoods, but they only control no more than 10% of those lands in terms of ownership, right? So the question arises, how do we actually navigate the trade-offs in terms of social benefits and benefits to nature and of nature in thinking about governance in an adaptive framework? And so here I'm going to share some insights from some of my long-ranging research projects. I'm going to focus on two kinds of research projects, two kinds of land systems, one in terms of tropical agroecology, drawing primarily from Mexico and Latin America, and the other on urban ecology, drawing primarily from cities in the United States. So in southern Mexico, particularly in the southern part of the Yucatan Peninsula, I've had research ongoing since the mid-1990s. This is, of course, the heartland of the ancient Maya civilization and no stranger to anthropogenic long-wave land use and actually adaptation to long-wave climate change as well over the past millennia. And in this context, I focus actually on the region of a large biosphere reserve, a United Nations Man and Biosphere signatory, where there is also prevailing concerns because of being a hotspot both of deforestation and of biodiversity. So in that context, there are contrary sorts of motivations and visions for this landscape, ranging from agrarian futures and compulsions and economic needs, all the way to more conservation needs, with an in-between focus on how do we actually affect perhaps compromises and conservation with development in this context. And I want to point out that this tension is actually central to the two prevailing paradigms of nature conservation globally today, which is, do we protect nature by sharing land for both nature and human use, or do we protect nature by sparing it from human use, right? So there's a land sharing versus a land sparing paradigm. So land sparing will actually separate out the zones for conservation versus use. Land sharing will actually co-locate those functions in the same area in a multifunctional way. And those paradigms actually need us to truly understand how land is being used by the local populations and by multiple kind of sectors and stakeholders. So this is an example of spatial modeling in the southern Yucatan that actually highlights that deforestation and reforestation probabilities across the landscape are really driven by a myriad factors ranging from biophysical to anthropogenic. But in particularly, I want to point out that policy factors are a huge driver of deforestation and reforestation. okay? And in particular, policy factors have unintended consequences. So even green policy instruments operating on the landscape have the effect oftentimes not of stopping deforestation, but displacing it, right? So there's spatial contagion effects that become incredibly complex and important to understand in trying to affect governance solutions. Over here, I'm also pointing out that in these land systems, particular stakeholders such as smallholder farmers are actually extremely heterogeneous. They don't operate with the same decision logics, and it is incredibly important to understand the diverse decision-making rationales involved, and also important to understand that the dominant strategies by people are not necessarily something that translate into the dominant land covers at the landscape scale. So there's a disproportionality here to keep track of. In this landscape, recent data also point to evidence that we are witnessing a regime shift from a formerly land sharing landscape with Sweden, mosaic agriculture, traditional agriculture, to a more land sparing regime with all kinds of implications, both for landscape level diversity and biodiversity, but also for territorial sovereignty and indeed justice. So switching to, let me see how we're doing. Switching to an urban example, I draw from a study that several collaborators and I have engaged in over the past decade plus that really looks at urban residential landscapes and points to similar questions of complexity. So for one thing, we find that relative proportional tree cover in urban neighborhoods are, and I am out of time, so are actually disproportionately sort of driven by multiple anthropogenic and biophysical factors, but they're also rife with nonlinear relationships, and the emergence of different kinds of yardscapes in urban residential landscapes is a testament to the fact that there are operating policy instruments all the way from zoning to the presence or absence of neighborhood associations and homeowners associations that end up shaping the biodiversity in our yards and what sorts of ecosystem services our yards can actually generate. So I'm just going to end with saying that we need to understand the complexity of land systems as coupled social natural systems, and particularly understand the ways in which institutional drivers operate to shape landscapes and the ecosystem benefits associated. Thank you.
So greetings, everyone. Thank you for being here in attendance and for watching online. My name is Professor Dr. Christopher Williams within Geography and Environmental Sciences, and I'm happy to present to you today a little glimpse of what it is that I do in my research program as an example of the exciting work around environment at Clark. I direct a research lab that I call the Biogeosciences Research Group. And broadly, what we study is forests and climate. We have a diverse set of funders and collaborators, which are illustrated here. We get this diversity partly because of the range of topics on which we work and the way in which we bridge from basic research to research that has real impact in the world and that is engaged with policymakers, with decision makers. We gravitate to use-inspired research that has real application and that answers timely questions in a way that meets decision makers and policymakers where they're doing their work. We try to work on things that are important to society, and we're excited to keep doing that here at Clark University. One of the things we specialize in is big data geocomputation. I am, after all, in a geography department. We bridge that or merge that with computational analytics and analysis and modeling that allows us to bring things to market in a way that's different from what a lot of other institutions and university and programs do around the world. We bring this arsenal to answer questions broadly about how changes to the face of our planet are influencing the climate system. As you've been hearing from other speakers, one of the things that makes Clark research in this area really special and unique is that we don't stop at the basic research. We have foundational basic research, but we bring this to applied science, applied applications in the real world, and there we don't stop either. We go all the way to outreach and education that reaches service to society. Working across this range, for me and for all of us working in this lab, brings a real vitality and enthusiasm to every day. It makes our work more relevant to society, and it makes a more vibrant and engaging environment for our students so that they see not just the research in isolation, but also the real-world impact that it has in practice. So today, it's my pleasure to have the chance to offer a few examples of the work that we do and how we bridge from basic research to broader impact in the world. So the first example is this. Almost every day we see a new headline about a new commitment to plant trees, to slow deforestation, to expand forest cover as climate actions to help fend off the climate change crisis. But few of these initiatives have good intel on how effective they'll be at cooling the climate system. We're using observations from satellites, measurements from forest plots on the ground, and high-tech analytics to figure out where tree cover would best serve us to cool the planet. This is one example of what we found. We found that forests cool in many places, as was expected, and that there's a lot of geographic variability. And maybe most importantly, that forests, not everywhere do they cool the planet. In some places, the presence of forests actually causes a warming. Here, it's shown in the reverse because we were analyzing forest loss. We were analyzing the climate impact of losing a forest, and you can see across much of the Intermountain West in the United States, planting trees in those places will have actually a warming effect instead of a cooling effect on the climate system. Or losing trees in those areas would have the opposite. They would cause cooling. Unfortunately, there are quite a lot of companies that are out there looking to plant trees in exactly this environment. We're trying to bring truth to that reality. This is because forests are darker than the surfaces around them. Other surfaces tend to be much brighter. It's kind of shown in this image. Partly it's because of snow cover and the highly reflective nature of that snow cover, but it's also because of the bright background soils and how that contributes, a reflection of solar radiation sending it back out to space. Decision makers are starting to use our data and to use these data in their practice to identify priority areas for expanding forest cover that would cool the climate system, and also to mask out areas where, in a sense, there's a no-go for reforestation activities, where it wouldn't make sense to avoid forest loss or to increase forest cover as a climate action equivalent to avoiding emissions of fossil fuels. This work is currently funded by the Nature Conservancy to take it to a new level. This is part of Jeff Bezos's Earth Fund and their very large award to the Nature Conservancy to take this analysis and scale it up to go global and also to go much higher resolution than the large blockiness that you see in this picture, to bring it down to the scale of decision makers, policy makers, and get it into their hands so they can actually use it on a day-to-day basis. We're delivering the data products as part of a decision support interface that makes it easy for practitioners around the world to figure out the potential climate solution associated with expanding tree cover or avoiding forest loss, and where that really doesn't make sense. So that's the first example. Here's the second example. It's related. We all know that forests soak up carbon dioxide out of the atmosphere and that they store it in wood and soils. And we're also learning now how much, how fast, and for how long. And that's what our research is about. Diverse institutions from state governments to conservation organizations to individual landowners and even banks and corporations are asking how much carbon their forests are taking up. They also want to know how this can be credited as a climate action. Our lab has used data synthesis, geocomputation, and computer modeling skills to fill that information gap. The map shows one of our results displaying patterns of areas with high carbon and high carbon uptake and removal by forests, and other areas which are less active at removing carbon dioxide today. We're writing this up for scientific literature, but that's not where we're stopping. As Dr. Carr also suggested, that would be inadequate. We're going much further than that. We wrote a public report and posted it freely online. We made our data sets available freely in formats that are readily accessible to potential users. And in the past couple of years, I personally have conducted over 30 workshops, press briefings, communications, and correspondences with state and federal officials, with non-governmental organizations, conservation organizations around the country, communicating not just our results, but also about the opportunities for putting them into practice. We've delivered custom data sets in all sorts of formats, including in state reports. We've posted our data set online in an interactive web mapping tool that's hosted by the Nature Conservancy. You can fly through our data there. This is just one high-level example of the patterns that are displayed. And people even from the US Forest Service tell me on a regular basis that
They're really learning about forest carbon and our forest resources just by flying through these data that are hosted in this location. It sparks a lot of discovery, a lot of curiosity, and I encourage you, if you take a moment, to take a look at your favorite place, your backyard. Here's one example. You can zoom in to the scale of a city and even draw a polygon to analyze how much carbon is in that landscape, what we expect in terms of carbon uptake in the near future, and how much that could contribute to climate change avoidance. It's research like this in service to society that really gets me out of bed every day. As I said, we're also packaging this for individual states so that they, and we're interacting with their offices of conservation and climate and environment to help them understand not only the inventory reporting that they can do with our data sets, but also the planning for climate action with forests that we hope they'll do and that they are indeed planning, in part using our data sets. So President Fithian has inspired us to think big about a culture of possibility, and by leading with renewed appreciation for the impact that it has in the world and that Clark has in the world. I hope that the examples you're seeing today will inspire all of us to think about how we can do more of that and to celebrate what it is that we're already doing and think of those as special opportunities for expansion and growth. Clark definitely has, it's a smaller institution with a very seriously outsized impact in areas such as this, global and climate change. We have impact that gets our name out there, impact that provides opportunities for our students to be inspired and to learn collaboratively, working in teams on our projects and as members of those projects, and to do great work of importance that serves society and that helps them launch into the world for lives of fulfillment. And that's something that we're all very proud of. I'd like to close with an example of one area that I think is particularly ripe for potential future growth at Clark. Society is on the verge of a massive transformation of energy production, in transportation, in heating, in cooling, in the way we power society at large. I don't think people realize just how huge this transformation will be, and I'm sure that people don't realize just how close we are to being able to solve this problem with the technologies that we have at our fingertips. That's why I'm excited today to propose the possibility of a new incubator at Clark University around the transition to clean energy and a climate-safe future. Its goal would be to equip society with the tools needed to envision and to design a transition from where we are now to where we need to go in the future with deep decarbonization of society. By building from my team's foundational work in natural climate solutions, we're well poised to roll out a new research portfolio and applications domain, a hub that would perform outreach and education around climate solutions in our built environments. Solutions that reach the scale necessary to truly protect the climate system at the global scale. Society needs bold, new design thinking on this crucial topic, and I think Clark is just the place to help fill this gap, along with other institutions. I hope we have that opportunity. Thank you.
Okay, I would like to move us now from forest to the coast and think a little bit about how we react to a changing climate. Ed spoke about climate adaptation in one way, thinking about how people feed themselves. I'd like to talk a little bit about how we protect ourselves from hazards that are caused by a changing climate. So climate change impacts, one of the major impacts, particularly around this area, includes sea level rise and an increased incidence and severity of coastal storms. These obviously have wide-ranging impacts on the things we care about, on our homes, on roads, on the systems that we use, beaches and mangroves and wetlands. And a myriad of adaptation options are available. All involve costs and trade-offs. If you read the headlines, you might think that the primary goal is to protect the things we build, our homes, our roads, right? But unfortunately, when the most common approaches to protect the things we build threaten the other things that we value, wetlands, beaches, natural systems, right? And so thinking about how we solve this crisis requires an understanding of how human and natural systems interact along the coast. All of these solutions must confront uncertainty. Right, so here we have just some simple graphs about projected rates of sea level rise globally and across the continental US. And even just considering these averages, you can see a wide range of uncertainty. Right? And as you get even narrower, looking at specific areas like, say, Massachusetts or Virginia, you see even greater variability, not only year to year, but week to week, and exacerbated by storms and other flashy events. So how do we adapt? Right? What I'd like to use is just a simple example of one system that has extremely high value to people, right? Salt marshes. Right? So coastal marshes, right? These are highly valued systems, right? Whether we recognize it or not, these provide a wide range of services that we value. They filter water, they support wildlife, they protect us from flooding along the coast by absorbing floodwaters before they can flow inland. Right? These are just a few of the many services they provide. The challenge, however, is that we armor the coast, right? For example, building seawalls and groins to protect the things we build, right? They can squeeze out those salt marshes and other natural systems. As the water comes up, they have nowhere to go because they're confronted with this hard concrete wall, for instance. And so they get squeezed and they drown. It's called coastal squeeze. And so when we think about, well, how can we protect these valuable natural systems while at the same time protecting the other things that we value, right? And so we really have to understand the dynamics of how natural systems work and how human systems work, recognizing that preservation is costly. For example, one of the ways that we would preserve salt marshes is to purchase and preserve or otherwise preserve undeveloped, unarmored land where those marshes can migrate as the waters rise, right? But that's costly. So let's think about what might happen to these systems. This is an example from the Virginia Coast Long-Term Ecological Reserve, LTER, and this shows the blue in that color is salt marsh, right? And this shows what's moving from left to right, what is anticipated to happen, what we predict to happen as sea levels rise, from current levels all the way up to a fairly pessimistic level of sea level rise. Keep in mind that sea levels is rising in Virginia much faster than many other places in the coast. And so you can see that, that at high levels of sea level rise, that marsh is basically gone, right? And what it remains is solely due to the ability of that marsh to migrate inland into forest and farmland. So what do we do, right? Well, one thing that many organizations, such as the Nature Conservancy, are doing is seeking to purchase and preserve land for that marsh to move into as sea levels rise. But that's not free, right? And so how do you plan for that strategically? Well, you have to first figure out, among other things, what that land is going to cost, right? And so we can predict that, right? And so I worked with one of my graduate students who's now working at EPA, George Gardner, to try to predict across the eastern shore of Virginia where this area is, well, what would this land cost as you move forward so you can make effective plans? But you also have to consider some of the complexities, right? Additionality. That basically means what additional you get from your actions. Think about it. Not all land is going to be armored. Right? So you might spend money to preserve a parcel of land that will never be armored or protected, and so effectively you've wasted your money. Right? So we have to think about where people are going to armor the coast. We can predict that as well. Right? And so taking observations of where armoring is, cross-referencing that against what we know about the landscape, we can predict where and when armoring will occur. We can overlay that with the costs, with models from coastal geomorphology that will predict where those marshes will go. And we also have to consider that you don't want to put your eggs all in one basket. We don't know what sea level rise is going to be, and so we have to come up with robust alternatives that mix and match our preservation investments, much the way you mix and match stocks and bonds in a financial portfolio. And so we take all these systems together in a large natural human systems model to basically determine what exactly should we be preserving and where should it go, creating heat maps like the one you see here. And interestingly, it turns out that when you run those models, that in fact, what we're doing now isn't particularly optimal. right? If you look at what's being preserved on the land right now, it's all low-lying marsh and forest land. And what's going to happen over time is that that's going to disappear, right? And if we develop all that upland, the marsh is going to have nowhere to go. So what our model shows is that, in fact, we should be spending much more effort preserving what is now slightly higher elevation farm upland. That's where the marsh is going to go when it's particularly highly valued in the future, when marsh is very scarce and otherwise won't have anywhere to go, right? So now, as mentioned by our panelists, the challenge is working with the folks down on the Eastern Shore to figure out how to get from where we are, 14% of that high elevation agricultural land that we should be targeting, to somewhere between 60 and 92%, which is where we want to be, right? That's not easy, but the first challenge, before we figure out how we're going to get there, is to learn where there is. And with that, that's the end of our presentation, or presentations. And what I'd like to do first is to open up the floor. I'd like to first thank our presenters. We've just spent some time speaking about some of the work we're doing here at Clark, and I'd like to open up the floor to you, the audience. Any questions, comments for the panel? I see Doug. You'll have to hold your hand up high because I can't see with lights.
Yes, up front.
Please. Yep, go ahead.
Oh, good, there's a mic.
Yeah, thank you so much for the wonderful presentations. So my question especially goes to Professor Edgar about your work around adaptation, especially in the LDCs, given your extensive research in Africa. So I know there's an issue about loss and damage and how it's being reported, especially from the least developing countries, and the role like funding plays, like especially with your role at the GAF. So I know the IPCC has like most scientists, and Africa is so underrepresented in the scientists in the IPCC. So which brings an issue, I think maybe there might be issues of loss and damage in Africa that are so underreported, so which gives a challenge on how to address some of the issues. So like what could you recommend given your work in Africa? That is it the scientists in Africa who lack like some kind of socio-technical capacities that need to be built for them to take part, in the global environmental adaptation processes? Thank you.
Thanks. First of all, it's a really good question. You've got several pieces to it. So let's start with the participation of African scientists in large global assessments. Maybe 30 years ago, the barrier was capacity. It's not the barrier anymore. The barrier now is that most of my colleagues in sub-Saharan Africa, based even in universities, the salaries frankly aren't that good, and so they're taking on consultancies and other kinds of work, whereas the IPCC and other kinds of assessments are volunteer work. They literally cannot afford to be on the IPCC. So that's actually the structural barrier, and there's a real conversation happening inside the IPCC. I don't know what's going on in IPBES yet, about actually paying some people for their time to do this work, to balance some of that out and to create more of those opportunities, because that's clearly a structural issue. But the absence of some of those folks, and therefore a question of sort of the diversity of the people conducting the assessments, the inclusion of people in those assessments, yeah, it does shape the content of them. The issue of loss and damage, though, is a different challenge. I don't think there's a single person on the IPCC, the 270 authors, at least in the working group I was in, who would say to you that loss and damage isn't a real thing. And by the way, when we talk about loss and damage, we're talking about the losses and damages experienced by people as a result of climate change. Very often climate change they did not create. If we're talking about like sub-Saharan Africa here. I think everybody knows that's real. The problem is that's a political question, because the words loss and damage have become, in the climate negotiations, somewhat toxic, because that implies an obligation, and then there's arguments about how you meet that obligation. So that's actually the bigger challenge. But we do know where the impacts have been. I think we can always refine that, but that's not our barrier. It's a barrier of, again, Why aren't we getting some of the scientists in? And that's a structural problem. And then there's a politics problem around loss and damage. But I think that just speaks to some of what you heard from everybody here. That's why we can't just do basic research. That's why you actually have to engage in the political processes. That's why you actually have to work with your colleagues on a range of different things to think of ways to get more people into these whole processes. Last really quick point on this. One of the greatest things the United States ever did in terms of building capacity in other parts of the world, the US government used to directly fund the PhDs of a lot of people from around the world. They used to just pay for it to come here and do that. Most of those programs were ended in the late 90s and early 2000s. And it was a disaster to end them because a lot of the capacity we have in a lot of the countries, a lot of my partners were trained through those programs and it built tremendous capacity, but we're seeing an erosion of that capacity now. And we really need to find ways to spin that back up in the future so that we can actually see long-term building of capacity inside these countries. So that's just a last point on that. Thank you. It was a great question.
Thank you. So this question was inspired by initially I guess, Dr. Williams and Dr. Carr shared sort of similar frameworks for looping research and policy and implementation. But I was wondering if any of you had more to speak on how frameworks can be communicated with like your average NGO trying to make a difference. Like, how do you take those decision support tools from huge high-level decisions to better communicate them to everyone?
Yeah. Okay, I'll start. First of all, a lot of time. It takes an immense amount of engaged conversation. Second of all, you really have to listen to where they are and what they're interested in, because just talking at people doesn't get the job done. So listening is actually one of the first parts of the job. Figuring out why they're there, what they're curious about, what their needs are, and then ultimately doing the work that helps answer that. And oftentimes we've found that we actually had already done that work, but we just didn't communicate it in the right ways, or we didn't package it, and a subtle change can make all the difference. A third piece is building confidence in the work that we've done, and part of that is helping to deal with what I'd call channel confusion. There are other groups who have done things similar to us. Sometimes there are subtle differences that we academics spend a lot of time worrying about, and as we should, but oftentimes they point in such a similar direction that it ends up just being a miscommunication or a confusion rather than a real barrier. But we need to demonstrate that our data product shows something similar to someone else's data product and talk honestly and openly about the advantages and disadvantages of our technique versus another, or where maybe they're very similar and you could use either and have some humility about that. So those are just a few of the key elements that I would put forth, and I'd be happy to listen to what others offer.
I would just like to make one additional comment, that we also, the length and depth of engagement is important, right? I often worry a little bit about what I call parachute science, where you do your work in a lab and then you launch yourself into a policy climate and say, oh, I'm here today, I'm here to share my wisdom and my intelligence. And the people who have been there for their entire lives and have worked there, well, who are you and why are you coming in and talking at me, as Chris mentioned? One of the things that we have to constantly teach ourselves is that to build that trust, to build that authority, you need to sit with people making decisions. You need to engage with them for a long period. For example, I didn't speak about it today, but a lot of my work is with US EPA, and I've been working hand in hand with folks from in the state and federal levels of EPA for decades, right? And so there's a certain degree of trust that's engendered by that allows us to work together to solve problems, right? So we have to get out of our classrooms, get out of our offices, and live in the real world with people making decisions. And that's what's going to enable our work to make a difference.
100%.
If I could follow up briefly as well. So in a lot of my research, I've engaged at kind of global policy platforms and programs, but I want to contrast that with a very local example. So along with a group of Clarkies, students of mine, we are actually partnering with Mass Audubon on a very specific climate resiliency project that they are embarking on as we speak. It's going to be a long-term effort. It is basically a watershed restoration effort, a hydrological restoration effort in Broadmeadow Brook. Many of you may have been to the Mass Audubon Broadmeadow Brook Sanctuary. So they're really interested in kind of the environmental justice aspect of this as well. So Broadmeadow Brook is also an environmental justice community, which the state of Massachusetts defines on language isolation, race, ethnicity, income criteria. And one of the things that Clark is assisting them with is to conceptualize what equity can look like in an ecological restoration program, right? And kind of think about reversing outreach to in-reach. How do we actually think about who the community is, right? And their experiences and engagement and values in terms of the neighborhood and the local environment and their exposure to varying degrees of flood risk, and think about using that information to shape the restoration program, right? So to really flip the outreach. But it too is a long-term commitment, as both of you have laid out. This is a commitment for the long haul. So we're, I'm excited to partner in this for hopefully 10 years, but we'll see.
Longer.
I love working at Clark. They said it all. I mean, no, seriously, it's fantastic. They said it better than I would have said it. That's perfect.
Awesome. Other thoughts, questions?
Thank you all for your presentations. This has been a fascinating panel, and I'm particularly, I don't have that much recent experience or exposure with Clark's scholarship that's happening and research. So I'm really impressed by the amount of data that you all seem to have.
Yeah.
I want to say in your back pockets. So in my mind, this raises issues about data governance and who, where the data comes from and who actually gets to make decisions about what happens with the data. And so I'd be interested in your comments along those lines.
Yeah, I can jump in, but do you want to start?
Yeah, I can just speak briefly. That's such an important point. I mean, one of the things that's wonderful about a lot of the data that we're using, speaking for myself, but also kind of projecting others, is that these are data in many cases that we've created, right? Linking with data that are already out there, right? So in many ways, we have a lot of authority and flexibility to share that data, to make it available. And increasingly, one of the things that we're seeing, and certainly in my projects, and I would assume with others, is that these data are increasingly being shared on public platforms, right? The data that I just showed you, including data from my other projects, those are all being posted in publicly available locations, right? So whenever we publish results, those data go out there along with the model results so that people can replicate them, so that anyone can go out and find those data and do what they want with them, right? So we're not worried about kind of protecting our data. Once we get results, we want them out there. We want them to be shared. We want people to tear them apart, not only to use them, but to be able to question our results, to say, well, do we stand behind what we do? And I think we do. And so we want people to be able to push on our data, push on our models, and make sure that they hold water.
Should I jump in?
Go for it.
Yeah, so it's a great question, and it comes up a lot for us because we do work with big data, and we procure data sets, we produce data sets, and we serve those to the public in several different ways and formats, and it's not always effective. We try to make them, our goal is what Rob just said. We want them to be publicly available. We want people to be able to use them. We want to discover the warts and see them in practice. That's why we made them, after all. And so that's our aim. And one of the places we post data sets, for example, is a data archive and distribution center maintained by the Oak Ridge National Laboratory, a DOE site. We also work with NASA a lot and post our data sets there. And those are great archives and inventories, but we've also found that oftentimes it's not just about posting a data set, because they're massive. Very few people know how to work with the scale of data we produce, and yet many people really would value information content. They value the data subsampling opportunity, and so we've started to do things differently from the way we used to do it. The community of scientists has gotten much better in this regard, that we now actually, even when we submit a journal article, it's a mandatory requirement that our data be publicly posted. But that can mean a lot of different things. Sometimes we post through the Nature Conservancy, and they've been a great partner. It's not always the same longevity and long-term curation that we would get out of one of these other servers. Sometimes we now post through interactive web interfaces. And for me, honestly, it's great for people outside, but it's wonderful for me as well, just to explore my own data sets. I learned so much by investigating them on these web tools, because I can fly through them and discover things on my own. And so it's been a really significant part of our work to conceptualize how we should do that better. And we hope that it's having the right effect. Lastly, I'll just say that README data files are very important, but that's not enough. Kind of to Ed's point, Ed Carr's point, we need also to have kind of user support guides with case use studies that illustrate where our data, what the applications for which our data sets are appropriate, and applications for which it might seem appropriate but really wouldn't be. And we're not only producing that in printed form and documents that are posted alongside the data sets, but also trying to do a lot of communication outreach when, as people come to us and ask about those potential applications. It's actually a big part of the work.
Any other thoughts on that?
I'll go in a slightly different direction, but really quickly. So I work with ethnographic data. I work with social data from people, and there's two kind of major challenges there. But I'll go with the easier one, The US government hasn't the faintest idea how to archive ethnographic data. No, literally, they don't know what to do with it. And as a result, they've just started exempting projects that use it from actually having to archive the data because no one knows how to put it up or what to do with it. And that creates a huge problem because, of course, then it's not publicly available unless somebody asks. Even if you have really well anonymized all that kind of data, it can be a real challenge there. The other side of it, and this goes to another thinking on data governance, is who produces, who gets to use it, that kind of thing. My lab's been able to get a lot of money to train people up in capacity to do data collection. We have utterly failed, despite repeated efforts, to get the money we need to build people's capacity to do the data analysis in other places. We, and I do mean my lab, me, leaning really hard on USAID, the Agency for International Development, and its new climate change strategy to try to make this one of their priority areas. And we're part of a bid, Clark, actually many of us here at Clark are part of a bid on a huge $50 million adaptation mechanism coming out of USAID, where we have pushed very hard for that being one part of what they need to start doing. If they're not going to pay for people's PhDs here, can we pay for capacity building in these places so that folks can, in fact, govern the use of that data where it came from, instead of it always being governed here?
So we've got about 2 minutes, and what I'd like to do with that little bit of time is to ask those on the panel, any other comments, anything else that you would like to mention in the last few minutes before we leave?
I have one, and it pertains to the previous point about data. And I think one of the really important conversations that we're having, that we should be having, is about the difference between data and information and knowledge, right? So, and I think, to me, your question actually was about also sort of, kind of knowledge and whose data,
Yeah.
right? So, kind of, yes, social and ecological, but even on the social side, whose knowledge is being represented, and do they have a say in co-producing your research questions, right, in the first place? And that is very much a direction that these global platforms of scientific research are embracing really actively, and certainly the Global Land Program. In previous eras, we were more of a scientific research institution, and we still are that, but we are partnering with the International Land Coalition, with Via Campesina, and other sort of social movements that are fundamentally about land sovereignty and kind of curious and concerned about representations of their knowledge in these, big data systems and so on. But it's a complicated terrain. I'll just leave it at that.
Right. Go ahead.
So the only thing I was going to say really quickly is one thing, and I'll say it very, very fast because that's counting down really fast. What struck me listening to this is how you see how much the Venn diagram is here. like how much overlap there is, but how people keep coming at it from all these different angles. That to me is not a problem. That's exciting. That's what we need to do. We have to come at these challenges from as many different angles as we possibly can, because none of us have truth. We have a lot of facility with the stuff we know how to do. We're not going to solve any of these problems by ourselves. We're not working in stovepipes because that's not effective. It's thinking about how we work together. In a place like Clark, you can do that. We're small. I know all my colleagues. I know a bunch of people in this room. That's not always true at these giant research universities. We have an opportunity to do something a lot of people don't get to do.
And with that, I mean, I think that's a wonderful place to end. We are out of time, just with the idea that this is all integrated, right? We're working across disciplines. We're working with the users. With that, I'd like to thank our panel. I'd like to thank you, the audience, for attending. We look forward to working with you as together we try to confront this challenge of climate change. Thank you. Thanks.
Okay, good.
Hi, everyone. Welcome to our session. So today we are at the technology session. We're going to talk roughly about an hour about our research work. So I guess we're supposed to have one more person, but he's not here yet, so it just started. So we want to, everybody going to have like a 15 minutes talk, and then if you have any questions, just feel free to ask, okay? Yeah, maybe we should start. Yeah.
Go ahead.
All right, good afternoon. So my name is Shuo Niu. I'm currently assistant professor in the Department of Computer Science. I joined Clark in 2019, so this is my third year here. So I'm very happy to be a part of this. And I want to congratulate the president, Fiance, for his inauguration. And I'm celebrating by president some of my recent work, okay? So my main research is on social media. So before I jump into the research topic about the video sharing, I want to briefly explain what I'm doing. So my research area is called human-computer interaction and also social computing. So this more smaller area is called social computing. Human-computer interaction, you can see the three words in it, is human, computer, and we study the interaction between them. Maybe some of you think all the computer scientists or all the researchers in computing area are some like a technology geek, and they don't know anything about the human beings. They all know it's robots or something. That's not true. Okay, so like me, I study the interaction between human and the computational system. So half of my work actually involves human. So like I'm the person in this area to make the technology more feasible and easier to use, and also solves a lot of ethic issues, equity issues, to make the computational system be better serve the society and also individuals. So my particular interest is in social computing. Social computing is the area to study the collaborative system, like social media or the Snapchat or mobile phones that connect people from all over the world. So we want to use some of the computational methods to understand how people use social media, use computational systems, and also how those systems can be designed to better serve the population. So my recent research, after I joined Clark, I shifted my research focus a little bit towards YouTube. So raise your hand if you have ever heard about this website. Okay, I will be surprised if anybody say I never heard about it. Who has visited almost like every week? I see quite many. I'm not going to be surprised if you, most of us have used this, heard or used this website. So according to a Pew Research in 2021, believe it or not, YouTube is actually the largest social media in the market. It's even surpassed Facebook. So 81% of the US adults have been used YouTube in the past, I believe it's in the past months. And then, its competitor, TikTok. Everybody heard about TikTok, right? The TikTok is also quite popular, and it's getting more and more popular nowadays. 95%, they're especially popular among the young generation, right? 95% of young people between 18 and 29 have used YouTube, and 48% of people between 18 and 29 have used TikTok. So you can see those websites are getting more and more into people's life, and it could become a part of the thing people kind of, especially the youth, are using every day. So what do we see on YouTube or TikTok, right? We probably see someone travel all around the world, and we see what they say. All of those vlogs, I believe everybody, if you want to visit some place, you want to learn about the place, you watch those videos, right? Or if you have questions about, how I train my dog, or how I cook a Chinese recipe, right? The first place you'll find probably not buying a book anymore. You probably just go to YouTube and find a video to learn it. And also for the young people, I don't know if the light is too bright here. I cannot see how many young faces are there. You are watching the games, right? You watch those, LOL games, and every time they have a game, you sit there with there and want to be a part of that. And also some weirdos. It's not weirdo, but believe it or not, there are actually millions of people are doing that. Watch other people's eating, right? So those kind of mukbang videos. You're a big pan of ramen, and in front of the public, and and when you watch it, you're gonna have saliva in your mouth. You're gonna feel hungry, right? And also another type of video, ASMR, that's also part of my research, is you whisper. It's a community of whispering. So you whisper to the others, just mimic some feelings of intimacy and relax your audience and make them feel comfortable. So you can see there are a very wide range of topics that are on YouTube and also TikTok. So it's not just one aspect of knowledge. It's actually rooted into your life and covers and connect you socially, emotionally, and also bring some and generate some kind of experience that you otherwise won't have in your life. So I kind of I'm intrigued by those effects, the popularity of video share platforms. Oh yeah, by the way, I read another article the other day. It's like by the end of, I believe it's 2030 or 2050, the internet, 70% of the internet traffic going to come from video sharing platforms. So that's also a huge thing, right? So because those things are getting popular and affect people from different aspects, my research kind of ask one question, how those video creators affect viewers socially and emotionally, right? Or us, especially young generation, are encountering those things every day, right? They're perceiving their knowledge from video sharing platforms, their social abilities, and also they're emotionally being moved by those creators, even though they don't really know the people they're actually watching. Right? Well, they know the people they're watching, but the people they watch are actually not their friends. They're not the people in life. They're actually a virtual person somewhere in the world, and then you learn it from them. So I want to analyze those videos on the platform to understand the potential effects of those video sharing technology and also the content of the creators, how they can affect people socially and emotionally. So before we talk, I actually showed the research. I want to talk briefly about how the YouTubers or the video creators, or somebody called it YouTube influencers, are different from our traditional TV media, right? So you think about that, the YouTubers, the video creators, they're not traditional celebrities that show up in the movie, right? They are mostly just regular grassroots person who demonstrate expertise in something, right? Like at least one person that I can recognize is Mr. Beast. Anybody heard about Mr. Beast? He's a famous person on the internet. He, one video I remember is he buy out all the used cars from a car shop and then just give it free to a random person. He made a lot of funny video like that. But he just doesn't look like a celebrity like Taylor Swift or Robert Johnson Jr., right? They look totally different. And those professional actors, they are acting, right? They have a script. They play in the movie. And the second big difference things is, their channel always seems about their life, right? So we have, if you're making a eating channel, you just eat different things every day, and then show it to the viewers. It's themed, right? If you have a game channel, you play a game every day, you do that, and then you grow your own expertise and build a community around you, right? But for movie star, they play different roles, right? Today they are a doctor, tomorrow they are different. They are a nurse. The other day they become a teacher. They play different roles. And compared to the celebrities, those YouTubers, they have a relatively smaller community. Right? They are known by less people, but meanwhile, they're more approachable. Right? If you message them or if you DM them on the social media, they might reply you. But if I write an email to Taylor Swift, I don't think she's gonna reply me. Right? So that sounds impossible. So you can see that on YouTube, you share your skills, and in exchange you affect your viewers socially and emotionally, and then you build a community around you, and then you become a virtual friends to them, right? And then those type of relationship are also built through those type of one-on-one communication. So so my research kind of trying to study those different phenomena by asking how YouTube content creators manage the interactions with the viewers and form a community of mental health support. That is mostly the research I did. I'm gonna be brief on what research I have actually done because I only have like 15 minutes, but that's kind of the highlights of the research projects I carry out. One of the first projects I did when I came to Clark is called Stay Home With Me. This is a hashtag called that's actually initiated by YouTube. It's for, during COVID-19, when the COVID comes, there's a national lockdown, everybody gets stuck at home. Mental health is a very big issue when you stay home for a very long time. You're gonna feel lonely and you're gonna feel disconnected from the community. And YouTubers actually reflect on that and decide to help. They launch some sort of a campaign, or you can call it a movement, to make Stay Home With Me videos to help people stay connected and reduce their loneliness. And then this type of movement actually attracted huge traffic. The With Me tag increased by 600% after the event. A lot of people are turned to YouTube to actually stay connected, to feel, to do something with the world, right? So to avoid loneliness. To study this one, I kind of being interested in this because this is the very first social media movement to actually help people during to reduce some kind of mental health problem, right? So there's no study before to study similar phenomena, and it's valuable to have a deeper delve into this movement and understand, like what Stay Home With Me videos have been made and how they relate to the COVID-19. And the second question I'm interested in is how does Stay Home With Me in different styles affect the social provisions in the video? Social provision is a psychology theory which says you need those 7 different types of social provisions to avoid the loneliness. Like you need your connection to your parents, like someone provide you intimacy, someone share interests with you, some type of guidance from a mentor type of role. When you are quarantined, you basically lose connection to all of those, right? I'm interested in whether those videos provide this type of social provisions and help you shield against loneliness. The last one is mostly about how does that affect, how different social provisions affect the viewer engagement, right? So which type of the videos are more popular, are going to be watched more times. So understanding those going to know, if we have some similar events in the future, how do we make videos to handle that? But so we use the YouTube Data API to collect the data. So we use a quantitative approach to analyze a large number of data, 23 videos between the beginning of the pandemic and the May 15th are collected. And then we also collect some of the metadata, including the likes, dislikes, subscribers count, comments count, etc. And then we analyze 42 videos in total. So some quick introduction about what do we find. The first thing is, like one of the questions that we annotate is whether the video mentioned COVID-19 or not. We kind of surprised to find that most of the YouTubers in their videos, they did not even mention COVID. You can see from the bar chart here, the 0 means no mentioning, and the 3 means mentioning a lot. You can see this largest scroll to the left. Why I'm bringing this up is because this is totally different from other social media like Twitter or Facebook, where a flood of COVID stressors or COVID-related information, go to the social media and cause a lot of stressful feelings, right? So we find that YouTubers are taking a totally different approach. They are trying to reduce those type of stressors to engage you into some other activities that's not COVID related. And even though we know that alert people against those crises, against the danger of COVID is important, but meanwhile, mental health is also important, right? We don't want to make people, if social media only make people feel stressed, they will, that's not the only one purpose of social media. So that's, in the future, we should have somehow consider leverage the creators' abilities to form a community, to form a space where people can temporarily relieve from those stressors and stay mentally strong. We also analyzed what type of social provisions the YouTubers trying to give to the audience. The most common one is called social integrations. That is the provisions that you need from friends and to share skills, learn some knowledge. So you can see that this one has most of the videos, 898 videos. In those videos, the YouTubers are sharing some skills, right? Like stay home and play piano with me, stay home and learn cooking with me, right? They are trying to make those type of videos. Second most common is a guidance. They are trying to share some knowledge and help teach you learn something like how to speak Chinese, right? They make those videos. The type of provisions that are not that common are the attachment, reassurance of words and the nurturance. Those type of provisions are generally obtained from like your mom or your parents or someone who can give you those intimacy. And it's not surprised because YouTubers are not showing some love or they won't kiss you in front of the camera to let you obtain those. But when we analyze the comments and all those the viewer data, the videos that actually show some intimacy, like showing those type of love, actually receive more views, right? So that's kind of hints that during the pandemic, people need those type of care, right? And they attract more viewership. That's briefly about the first study that I did. And then later on, I'm interested in another type of video called ASMR. Do we have any audience know what this stands for? No? Yeah, that's actually a very popular type of special videos that a lot of people are watching. They have millions of audience all around the world. ASMR stands for Autonomous Sensory Meridian Response. It's a neurological response reacting to like a tingling or whispering in your surrounding environment. If you don't know what that means, I believe like just think about this, you go to a barber shop, right? Somebody cuts your hair. When they move their scissors around your head, you probably feel like a little drowsy or those type of tingling sensations. That is a typical ASMR, but there are a whole lot of different things. And one thing about that is different people can have different response to different triggers, right? Like some people, when you hear like somebody ripping the paper, you're gonna feel those type of feelings, right? Or somebody, for example, rub something squeezy or or liquid, move some liquid around your ear, you feel those type of tingling sensation. That is also a effect of ASMR. So a lot of YouTubers, they're leveraging those type of effects to create a video type called ASMR videos. What they do, they just whispering near the mic, and then they ask you to put on your headsets, and then since the microphone, their speech gonna near your ear, they're gonna generate those type of fake feelings, and those videos are called ASMR videos. Believe it or not, there are 5.2 million ASMR videos in 2016, and then after 3 years, the ASMR video grows to 13 million. And if you look at the top 100 search words in the United States, ASMR is actually is at the second place. They are very popular on YouTube. And I think, oh, those videos are popular. Why they are, how people make it? What's the effects of that? Right? Why people are watching them? Right? So therefore, I'm trying to study the ASMR, including like, what are the interaction modalities? Are they touching things? Are they just whispering? Are they trying to eating things? Or are they trying to, doing some makeups or do some role plays? Those are different dimensions of interaction modality. And the second question that I explore is how do those ASMR design those parasocial attractiveness? Basically, how do they perform tasks? What type of tasks they perform, right? And how do they socialize with the audience? And how do they, what's the other one? Social, how do they trying to perform physically getting closer or virtually getting closer to the viewers by just manipulating the camera, right? How do they do that? And the last one is how the viewers express their feelings in the comments. So again, we collect a large number of data. We use ASMR to search YouTube, and we programmatically received to call this API to crawl the data, and we got 85,000 videos, and then we sampled 30 videos from them, and we perform a statistical analysis. So in sum, those type of ASMR interaction can be summarized into 3 big categories. The first one, as I call it, multimodal social connection. So those YouTubers are not purely just generating those sensational feelings. They are trying to socially connect the viewers. How do we know that? Because 70% of the videos have those virtual fake conversation, right? The YouTubers are trying to talk to you. That's make you feel that you are sitting in front of them and have a conversation with them, right? And also 25% also pretend to have a back and forth. They even pause that to pretend that you can reply. Like, hey, how are you? And then, oh, you're good, great. And then they put you into some like a back and forth conversation. All those social scenarios are gonna generate a social feeling. And more importantly, it's actually multimodal. They are leveraging a lot of interactions, right? Like sometimes they reach their hands with the camera to pretend that they're touching you, right? When you watch this video, you're gonna see the hands coming towards you. If you have a bigger screen, you're gonna have those sense of immersion, right? And that's also part of the second experience is called the relaxing physical intimacy. That is, just like the second picture over there, they try to touch you, have some mimic, some fake, mimicked physical interactions. And also when they try to, a lot of YouTubers put their mouths very close to the Mac, and then we wear a headset, you're gonna feel like someone is blowing their mouth or whispering near your ear, and they generate those type of intimacy. One interesting we find that is when the videos have those physical interactions, the viewers come and have a lot of more words related to what? Related to the relaxation feelings. So that they when they watch those, they say something, oh, I feel relaxed, or it feels good in the comments. So that's kind of indicates some benefits. The last type is called the experience of sensory reach activity observation. Those type of videos are a little bit different. Mostly they don't talk. They don't even show their human face. What they do is mostly like, for example, tapping the keyboard, or tapping some tiles, or eating food, or crack some objects. In those videos, they are trying to just immerse immersive audience into the perceptual reaction to different triggers. So the last type of study that I'm going to briefly talk is about, I collaborated this project with Dr. Kathleen Pomeroy. So it's about the drug addiction. So the drug, everybody know how severe the drug problem is in the United States, right? And the YouTubers are actually take their action to help with those events. So we kind of, I'm not going to delve deep into this, but mostly, briefly talk about what kind of videos are there, right? So we still use drug names and plus addiction to search to YouTube and get a lot of videos. So we found 3 major type of videos that are on YouTube. The first one is like the educational videos. They are made by a lot of psychologists or psychiatrists, or some people who think they are, they experience addiction themselves before, and they start to help people know what they have been through, to educate them. And the second type of it is a little bit controversy, where I think we should delve deeper into that. Is I call it disclosed addiction experience. There are a lot of videos the YouTubers just go on the street shooting a lot of videos about people's horrible life, lose their house, lying on the street, have a lot of addiction symptom. And I call it, it's like they're trying to get attention by showing others problem. And they have the name of helping them, but who knows, right? You're disclosing other people's addiction problem, and it might have some negative effects. And to Dr. Reese, they call it it's a scare tacit, right? So I don't know that, but Dr. Reese told me it's a scare tacit is not a good strategy to help people who have addiction problem. And the last one is a community of addiction advocacy. Those people are more activists. They are trying to help people on the street, give them food, give them water, or just to shoot the scenes of the street. And some of them are also like the live stream, or they use those live stream to call on people to donate or to help those people. So that's the most 3 types of videos. All right, that's pretty much what I have. Sorry for taking a little over the time, and I'll hand it over to maybe Hanan. Are you ready? Thank you.
So this one's next.
Yeah.
Okay, good afternoon, everyone. My name is Hamid. I'm Assistant Professor of Business Analytics and Information Management at School of Management at Clark University. So today I briefly explain about my research and also a School of Business plan for adopting blockchain technology and being active in cryptocurrency and related technologies. Okay, so at the School of Management, we have 3 major purposes. The first is teaching the most advanced topics to our students. Second is research purposes. We want to focus on both blockchain and big data concepts. So, and there is some interconnection between these two, which is our focus. And if you look at LinkedIn, there's new jobs coming up in blockchain and cryptocurrency. We want to have our students also be attracted in those markets and be successful. So we have, could have broader markets that they could join. So, but how it started at the School of Management? So we applied for an innovation grant, and it was under a Business Edge Technologies Lab, which basically we got the grant and we started to initialize our lab. There's a chip shortage, as you might know. So, but we plan to have it by the end of the summer. So, but we already through the grant, we already have some deliverables. The first, we develop a course on blockchain and cryptocurrency. So it's a start from concepts, then we go right into the hands-on experience. The students learn how to code the blockchain, then how to create some sample cryptocurrency, how to do trades and creating their own NFTs, so on and so forth. And the second part, which comes after summer, that we basically could finally get our computers and install, have the lab. So we started research. I already started some collaboration with scholars in the United States. So I show you a couple of papers that we just published. And also, then we will have a presentation, Informs conference on detecting frauds. It could happen both in cryptocurrency trades and also blockchain transactions. Dr. Alan Eisner and I were principal in this grant. So both of us have some experiment relating to research and also teaching new concepts for the business students. I also have 2 published papers. One is in exactly how to trade cryptocurrency, if you want to be a trader, how to use artificial intelligence to do trading, which since it could be more intuitive and easy to explain, I also explain a little bit of that paper. And also the second one is about blockchain technology and how companies adopt and this technology, and basically what is the characteristics of the companies or basically friendly through adopting this technology. So blockchain, and almost it's one of its first application with cryptocurrency, has some main reason that almost everybody now at least know about the Bitcoin. They do trading, so some could be ease of international transactions. So some countries even adopted as their official currency. So Honduras is one of them. So it led them to have faster, more reliable, and also independent international transactions. Some applications even happened for a recent international conflict, which was in Ukraine. So many people could be able to send funds to the people in Ukraine. which they don't have reliable banking system right now. So there's so many people do donations, and even in the Russian part, they are under international sanctions. So they be able to do their own trades, but since, which I explain later on, since the application of blockchain in international trade or cryptocurrency is transparent, so it's easy to basically cut those transactions that are happening in Russia. Also freedom, so people would be free of the government and their policies. So as you might know, in last year, the amount of printed dollars, which I mean printing, it just means creating like dollars, not exactly just printing paper money. So it was more than like last several decades. So, but some of the cryptocurrency, including blockchain, they have some limitation caps, so you cannot just print as much as you can. And also, if you want to have some updates, most of the majority of community should accept that. So it's not just one person, one government that can control. I know there is some issues. It's not perfect, but also there's so many updates in this technology. So you might heard of NFTs. So NFT is not a very new concept. So later on talk that during ancient times, even we had something close to NFT that now people are talking about. But at the end, if I just summarize it, so we have blocks of information, which each block depends on the previous block. And there is some basically authentication system that how basically a block of information could be valid, considering the fact the previous block should be valid too. One of the things that I'm going to teach the students, some of the validation, or basically how to maintain and validate transactions in the blockchain. So the most famous one is proof of work, which almost the first one happened for Bitcoin, and a student learned how to do coding, how to make their own proof of work network. I might also teach proof of stake. And you can see there's so many technologies. There's some of that they have some similarities, but basically there is a triangle of trade-off between how secure and how fast, and basically how you can have less computation. So you cannot have everything in all of them together. So sometimes you sacrifice a little bit of security, or you sacrifice a little bit of speed. So based on them, you might have different technologies. So each technology is not perfect, but at the end, they might have different applications. So one of the concerns that people are worried about blockchains is using blockchain crimes and dark web, and also, as I said, even some Russian investors are investing in Bitcoin right now. But the good thing is very transparent. People can use Bitcoin for crimes, but you can trace all the transaction and finally catch those fraud transactions. And it might be even much more safer, and secure, and reliable than dollar, which some countries, which I don't want to go to international policies, but they print fake dollars, but they cannot do it Bitcoin. Also, you might remember we had a power hijack in the United States, happened, I think it was like a couple of years ago. But for releasing the network, they asked US government to pay them in Bitcoin. US government paid them because they knew that everything is transparent and they finally can get all of the monies back. So this is one of the applications. So let's talk about a little bit of trading, which was the first paper that I just published. So almost everybody knows about that. So it's very intuitive. And even if you don't have any background in how to program those blocks, how proof of work, proof of stake, or other basically validation technologies work, at least people know they can make some money through having good trading policies. So I'm more fan of, I know there's trading, you might, if you just Google, there's so many courses in trading and techniques for stock, oil, even currencies, but I'm more fan of Bitcoin because it's much more transparent and you have more data. So if you want to do prediction with more data and with more transparent data, probably you might have better predictions. So this is the topic of the first paper. And I've focused on Bitcoin because there's more data. More other people also did some in literature, so I could adopt and use the technology. But let's talk about other types of cryptocurrencies. So blockchain was the first, but in terms of technologies, is not the most fanciest one. So you could also adopt more technology-based blockchains, and which happen in Ethereum and Solana, which are the more advanced type of blockchain, but still their currencies are not as common as Bitcoin. Also, in the course that I'm going to teach, I use Solana as a both blockchain network and also the currency, and I teach a student how to make their own currency through that Solana blockchain, and also how to do trade they make their own currencies and also their own NFTs. So on top of the most valid and the most common currency, as I said, Bitcoin is the first one, which is the most common one. Also, we have more fancier cryptocurrency based on more advanced blockchain. We also have some, I cannot find any polite term for that, but usually people call them as, sorry to say, shitcoins. So they'll just make their own currencies, and they get very active in social media. So they suddenly get so many people to buy those currencies, and suddenly they just sell them. So just look at this fluctuation in the price. I think somebody in the apex of the figure made millions of dollars, and then they sold all of them, and it's just nothing. So there's some frauds in the cryptocurrencies, so which is not the thing that I'm going to teach to the students. And let's talk about that paper. So I mean, I said the first paper that I'm going to focus here is about how to trade. So I look at so many data sets because let's say there's so many, I mean, China and India, they're large countries, and more than one, I think Dr. Fang can correct me, but China is about 1.4 million, 4 billion, sorry. So just assume how much of Chinese yuan currency could affect the Bitcoin price. So if Chinese people suddenly there's an increase in their currency or some drop in their currency, it might affect how they trade in the cryptocurrencies. Oil, gold, and even other cryptocurrency could affect Bitcoin prices. So I gathered those data, did some data preparation, and adopted some sample balancing algorithm, and finally used a very transparent model, which is decision tree. I don't go to the detail of decision tree, but it's among those algorithms that you can go under the hood and see what happens. So look, so the accuracy of prediction is 97, 98%, which is really good. On top of that, so you can use this model for different purposes. So you can focus on long time trading or short term. This is for just one-day trading. So what happens tomorrow if the Bitcoin price goes up or down? So this model could predict with like 97% if the Bitcoin price would go up or down in the following day. And it was before COVID area. So I want to use those any data before 2020, which there was not that much of fluctuations in the market. Then I said, okay, let's use the same model for the COVID-19 era, which is after 2020. As you see, the accuracy dropped to 87%. I've seen that my model is not that much confident on predicting the next day Bitcoin price fluctuation if it goes up or down. So if you look at this figure, there is some portion, the big portion of my data. So My mother is very confident if it goes up. So look at the right side of the figure and how it goes down. So for some part of data, which is majority, my mother is very confident. So with near 100% can say for some days it goes up and down. For some days in the middle, so my mother is not that much confident. As you see, the confidence is about 0.55. So I just said, okay, let's just drop those days that my mother is not that much confident, because maybe because of too much of fluctuation that didn't happen before, my mother didn't train well. So if I exclude those days that my mother is not that much confident, again, the accuracy would be near like 95%. So what it shows with the data that I had before COVID, I could predict the COVID Bitcoin price with near 95%, which is, again, it just shows the high reliability in the model. And also I made a tool, so if you look at my paper, you can basically download the codes and do your own prediction. I also made a GUI. So in this GUI, you can just drag and drop information of Bitcoin, and it just tell you what happens in the next day, which you see the prediction I made in the bottom. So it the confidence is 0.42, is very low confidence. So if I use my tool, do the prediction, it's just a 0.42, I don't suggest to do trading, because my mother could go, it goes up and down, but if it's like 42, 55, don't do that. So it just shows that my mother is not that much reliable for the next day. Okay, again, another part of the grant is developing the course. NFT is one of them. So you might see crazy prices of some NFTs that people cannot digest. So even I cannot digest most of them, but like the first tweet or these monkeys, they cost millions of dollars. But I'm not sure about if you heard about Ray stones. It's just basically large stones that people use for trading, like I think thousands of years ago. So they used to have physical Ray stones to just do their trade, maybe with some food or some outfits, but they were very heavy to transport. Sometimes they just dropped them in the river. So after a while, they never had the physical Ray stone, but they knew there was some Ray stone down the river. Still, they used them for trading. So they said, okay, there is 2 Ray stones in that river. So, and I sell half of it to you. You give me some food. So even in the ancient time, people used something that didn't have any physical basically appearance. They just knew something there and they use it for trading. I know it's not that much of, it might be a little different from the NFTs, but it still shows that sometimes people use something that didn't have any physical appearance anymore. They just use it for the trades. So our students learn how to create their own NFTs in Solana. And basically, if the good thing about the course, which even right now I have some students, they have individual study with me on blockchain and cryptocurrency. They use their knowledge to create their own NFT project, and some of them actually are working right now. I have this is a project that one of my students is working. So they have their own NFT through Solana, and they sell these pictures. What they do, which is their entrepreneurial idea, after selling those NFT, they use the money to buy miners, and these miners helps transaction Bitcoin net blockchain. So basically, this money helps them to have long-term support for their own project. So no matter if they can sell that much of NFTs or not, they still have some physical miners that, again, it gives them more stream of money. That's it for today. So thank you very much. It was my pleasure to talk about our lab in the School of Management and our current research, future, and also the course that we develop for our students. Thank you very much.
Great. I'm going to talk about virtual reality. So I have 3 areas. I was asked to talk about my work over the last year, which was my first year at Clark, explicitly with virtual reality in mind. So I'm going to talk about research collaborations, contributions to developer and classroom, and then VR and interactive fine art. So research collaborations, I wanted to start with a piece that I did a couple of years ago with Dr. Tara Peppas at SUNY Geneseo. And I start with this because I think this reflects a lot of the potential and powers of virtual reality in relation to sort of the research that we're doing here. So virtual reality, there's certain aspects of it that we think are really powerful, like the immersion part of it, and also the ability to embody the avatar that you inhabit in that virtual space. So for this scenario, basically you have to put on a VR headset, right? So that headset allows you to occlude the rest of the physical world around you. It often has headphones as well, so you're not hearing anything from that world. So that adds to that immersive element. The other thing that you do is you have a 360-degree 3D environment around you that you're experiencing in this virtual reality. And for this instance, we wanted to have something where these were graduate students in Graduate School of Education, and they were training to be teachers. So for part of their experience, they would be placed in the classroom, which was an extremely important part of their experience, being able to act as a teacher in a classroom. But there's a limited amount of time. They might only have 1 or 2 semesters to do that. They might only be exposed to a certain set of situations. So how could we extend that? So we were looking to have something that would happen in the graduate course as a cohort, allow them to experience that as often as they wanted to, and be able to discuss that. And also, another very important part of virtual reality that we used here is the ability to go through scenarios that might not be as safe in reality. So sometimes that can be physical situations, like working on an airplane, but it can also be situations where you're working with other people. So in this case, how you handle your interactions with another student, a young student, is something that you want to get right in the physical world, but something that you can play with or experience differently in virtual reality. So all of these made this a very particularly good product and combination for virtual reality, as well as the education department. So we did a couple of things. There's multiple ways to move in virtual reality, but we wanted to have something that increased that immersion level. So we made what's called basically room scale VR. So for the participant to be able to move across the room in the classroom, they also had to move physically in the VR, in the physical space as well. We also wanted to have a sense of time, because that increases your embodiment of the avatar in VR. So there's usually a situation where you're trying to interact with these other avatars, and you have maybe a dialogue system, for instance. So in this case, we wanted to make sure that they didn't rush through that dialogue system. So I made it so that they wouldn't actually progress unless they read out loud their dialogue. So the system would actually detect if they were reading it. So again, immersion, embodiment, this is sort of the empowerment of VR. So here at Clark, we have an academic innovation fund in partnership with the Graduate School of Management and the Becker School of Design and Technology. And so what we're doing there is the School of Management is crafting a dialogue tree based on approved business case studies. They have a number of these case studies. We obviously are only going to work with one right now to start with, but they've selected it especially because it will help with critical thinking skills for their students. And what we're doing on our side is we're developing the VR application to allow the students to interact with that case study in virtual reality, using a lot of those techniques that I mentioned, so that we have that immersion and that buy-in and that sort of embodiment of the avatar. So we also have, I'm going to talk about this a little bit, digital twins. So it's not quite related to VR, but it is in a second. But digital twins are basically a digital version of a physical system. So it can be something as small as, say, like a pond. So you might have a water biome, and you want to have that's in physical reality, but you want to have a virtual version of that and the data sets around it. But it can also be something as large as, say, having a digital twin of the entire globe's weather system, right? And that means obviously more data. And then depending on what the fidelity of that digital twin is, there's even more data and processing time. And an ultimate goal would be able to get it as close to a twin as possible, so you have more information about the space. Why is this important? Because right now, while we're able to do various things with collecting the information and the data, how do you use that data? And so there isn't really a standard yet, but one possibility that we're thinking of is that you could have the ability to use that data in virtual reality. So you'd be able to represent that data instead of just numbers or charts, in something that could be more accessible to multiple stakeholders. So there's an NFS grant application in the process right now in partnership with Clark's IDCE and the University of Mexico, UNAM, and my small portion, so it's about climate change. It's a whole system and a whole collaboration very exciting. But my small part is about the possibility of the visualization of the data of the climate systems and pulling from external GIS and climate databases and being able to put that into virtual reality so that we could look at that for policy analysis. So basically, how do we make something, that might be a set of numbers, how do we make that accessible to all the stakeholders? And one way to do that would be make an immersive experience so that you could be in that space. And of course, it would really require intuitive interaction. So we're talking about a UI UX system as well, and how you'd be able to manipulate that data, even if you're not a climate expert, for instance. And a framework to also allow those stakeholders not only to sort of experience the data in this way, but also to build their own versions from that, manipulating the data, and then being able to share that out. So you might be having a situation where you could share out worst case scenarios, but if you go into VR and embody that in an immersive space, that might have a powerful effect on how you're reading that information. You could also explain in a different way sustainable alternatives, again, by being able to be immersed in that space and embody it. And so we think this could be a potential standard for how you could do digital twin visualization, perhaps. And then contributions developer in the classroom. So this is my first year. So in the fall, I taught an FYI, Fundamentals of Game Development, which I've taught many times, but this is the first time I decided to do it with VR. This is an example of one of their projects in the last 5 weeks. And my point here is that I think it's important that we have these courses and the way that you offer these courses. The courses are critical because they're courses on technology that aren't abundantly available or accessible. And in fact, none of the students in my class had ever developed with VR, but most of them had never experienced VR, except maybe over at a friend's house once, many of them not at all. And there's definitely sort of a gate to feeling confident enough to work with new technology. And so I think it's wonderful to have introductory courses where you can present this and you can allow them to build a comfort level and then realize that they're totally capable of working with new technology and understanding the history behind it so that it becomes more approachable. So in the FYI, we were able to allow them to have headsets, access to headsets, and I use sort of like a building block technique and rapid prototyping so that we can get some results. I think it's really important when you're working with a sort of media and coding and programming and technology, et cetera, that you're able to see results that are applied, that you've been able to produce. So I like to have theory so they understand where it comes from, so it's no longer sort of scary, the data, and then creative exploration and application so that they can feel effective in their application of that. And the reason why is I like to compare it to, I have a course this semester, so in the spring for VR, that I'm co-teaching with Professor Amanda Theinart, and this is not for first years. So what does that look like in comparison to a first year VR course? And the idea here is that we assume that now that they have a comfort level, and they no longer think of this as something that they can't handle or manipulate, they know how to apply it in appropriate ways. So we go over case studies, but they are at this point able to recognize, okay, this is what makes a project suitable for VR versus just having it say on a PC, or maybe it would be a movie, or maybe it could be another medium form. Why VR? And you want to have that strong connection for them understanding what it brings to the table. And so they're able to work in groups to develop these. This is after 3 weeks, 3 different projects that we had brought to the table. And you'll see that they're not using building blocks anymore. They're bringing their own ideas and they're experimenting. And there's more depth to that because they're not so focused on just, oh my goodness, what do I do with the tech? They're thinking about how do I make this work so that the experience itself is something that's powerful. And I think that's something exciting to see in the development when you have a non-introductory course and being able to have an advanced approach to it. So yeah, the other important part of that is they also work in groups for that because I really do think that being able to have them introduce the technology and talk about it in a meaningful way and basically teaching it is the best way to learn. So we make sure that that's part of it and they're able to also introduce their projects to others because it's a learning and teaching sort of synergy going on. And then this is, I also teach game studio, which, yes, so in the fall, my game studio was in conjunction with our partnership with the ASA organization. And this is an example of a project that we did, obviously in 3D and VR, but we did it at the same time, both in PC and VR, because we're exploring sort of the differences between the modalities. So we know that there's a difference. We know that there's a lot of research on VR, but what about for learning specifically? So this is a very simple lesson. Basically, it's about assessing weight in a pet. But the idea is, would that make a difference with all other things being equal? And because of the game engines we use, so we use Unity and Unreal, we're able to develop for both platforms simultaneously with quite a bit of ease. So we're able to look at that and say, okay, if we develop this for both platforms, everything else is the same. So most of the code base, the visuals, the 3D effects, et cetera, it's really just the human interaction that differs. What does that say about the efficacy of learning from either of these? Is one platform better than the other, or do we not see a difference, et cetera? So we've built that, so now we're going to explore those differences in the future. And then this is my studio project for this semester, which was not intended to be in VR, but it's basically a 3D experience and actually has its own, basically it's a 2-player game. 2 people from different sides of the globe can play. They've never met. How do they communicate? They are not allowed to use any verbal communication, so they're using they can't draw or anything either. They have to use a small dictionary of symbols that are pre-existing, and how effective is that? How long does it take to do that communication? But the reason why I mention this is because we did not plan for this to be in VR, but we're at the point now with the techniques that we use in development to be able to try testing that out in VR now that we've done it as a PC development to see whether it actually has greater potential for communication and immersion in VR. And also, right now, when we were developing, every week we needed the people who were not programmers, who were not devs on that project to be able to still experience the project. So if you did modeling, design, level design, writing, et cetera, you didn't really want to have to play through the experience every single time, because in the beginning it might even be a little buggy. So how do we do that? We made a quick video instead. But a video is limited. Otherwise, we might ask them to go into Engine and scale through it. Not the best thing. But that brings us to virtual visualization of virtual environments. So what we could do is actually have those people who are non-programmers go in through VR to explore a 3D space in 3D, which makes the most sense. Do my 3D models look right? Is the lighting correct? Is the pathing correct? So that's another way to use VR, even in the development stages. And that's not just for games, that's also obviously for film. I'm sure you know that. But also, we're teaching an interactive theater class next semester. And so part of that is combining theater production techniques with game development techniques. And one of those, obviously, for set design, et cetera, how do you experience that and explore that before these things are actually built, right, and put in place? So we're going to use 3D visualization to do that in virtual reality so that you actually have 3D and 3D. And then, okay, I think I went to the right thing. Okay. Last thing is about fine art, which is an area that I do. So basically, I explore a lot of spaces, virtual spaces, in the sense of private virtual spaces. And I was considering the liminal transport between the physical into the VR space. But now I've sort of moved on to more public spaces for VR. So I've been exploring most recently the idea of avatars in public spaces, because all of my work centers on avatars. But avatars in public spaces, and thinking about how the public audience views you and your avatar, as well as how that changes your own performance. So performance it's been shown that your digital avatar affects not only how others perceive and interact with you, but how you actually perceive yourself and interact in the virtual space. But there's also studies indicating that how you perceive yourself as an avatar in a virtual space affects your actions outside of the virtual space, in the physical space. So for art, it's interesting to think about the performative aspect and how it changes your performance, how it changes your interactions with others in sort of a cooperative happening of art, which is what I'm focused on at the moment. And that's it for me.
Right, I guess we are open for a few questions if anyone has.
Okay.
No question.
No question.
Maybe I can ask you a question. All those projects are developed by students, or what kind of platform they're?
The first one was developed with a graduate student myself, but all the others are by the students. Yeah.
What tools are you?
Unity and Unreal, and for VR, the built-in VR technologies. For the SDK from like Oculus, we usually use.
Do they do the modeling from the beginning?
Oh yeah, they do the modeling as well.
Okay. All right, maybe we can just. Yeah, we have we have a timer here, so yeah,
we have 1 minute.
Yeah. Thank everybody for coming, and
thank you.
Yeah.
Thank you very much.
Yeah, if you have questions, let us know.
Welcome. Welcome to the session on Geography of Changing Lands and Seas. My name's Gil Pontius. I will be your MC and first presenter. I will be one of 4 15-minute presentations by me and my colleagues here. First, to my immediate right is Professor Deb Martin, and then Professor John Rogan, Professor Lyndon Estes, and Professor Karen Fry. And we are going to immediately warm up your brains. So I'll give you a moment to read this. Keep in mind, I know who you are. Dan, Sebastian, Yuko, Tammy. We might call on one of you to ask, who do you believe? when your government warns that 10% of your neighbors have a deadly contagious virus, the producer of a diagnostic test advertises that 90% of its tests are correct. The test indicates that you have the virus. Your Clark geography professor, that would be me, claims that you have a 50% chance of having the virus given the above information. Okay, Dan, it's you. Who do you believe? Correct, Dan. You came to the right place. Let's give Dan a hand. He's right on. Okay, but Dan was answering safely, because actually, if Dan would have answered any of the others, he would have not necessarily been wrong. In fact, it's possible that all of these are true simultaneously. How can that be? Well, that's what I spend my time thinking about and teaching a course that David, who's in the audience, and others have taken about how to make generalizable methods based on mathematical concepts that are also applicable to geography. So what we have here is a table, and in the columns are the categories of the truth. Either you have the virus or you don't have the virus. And in the rows are the results of the test. The test says you either have the virus or you don't have the virus. So the first claim was from the government, that 10% of your neighbors have a deadly contagious virus. So if we envision your neighborhood as 100% of your neighborhood, which is in the lower right, then in the column under truth, you have 10% of your neighborhood has the virus. Now, the producer of the diagnostic test is going to guarantee that its tests are 90% correct, regardless of the prevalence of the disease in the population. Well, how do they know that? Well, in the laboratory, they've done their experiments and realized that if they test someone who does have the virus, they're going to diagnose correctly 90% of the time. And if they diagnose someone who does not have the virus, the test is correct 90% of the time. And so we're going to take each of these columns, we're going to take that 10 and distribute it above, as 9 of it goes into you do have the virus and the test says you have the virus, and 1 of them goes below that. For the 90% of the people who do not have the virus, well, 90% of them go into that entry that has 81, because 90% of 90 is 81. And then 9 people essentially have false positives, false alarms. Now, your test comes back and it says you have the virus. So that means you're in the row that the test says you do have the virus. Well, in that row, there's 9 people who actually do have the virus and 9 who don't. And so of the 18 people in that row, half of them have the virus. And so that's how all 3 of those bits of information can be simultaneously true. But what I get concerned about is you hear on the radio, oh, well, the test is 90% correct. So people think, well, it's believable. It's like, well, you need to think a little bit more deeply about this. Because if you look at that, look at how many people actually have the virus. 10. How many people tested positive for the virus? 18. That's nearly double. So if you're giving advice to the hospital about how many people are sick based on just their test results, you're going to be dramatically overestimating the number of people who are sick. Well, what does this have to do with geography? Well, medical geography is phenomenally important. But Clark geography, and especially my field and the field of others, focuses on one of our areas of expertise is land change, of how the seas and lands are changing. And so this same analogy applies directly to what we're doing here in Clark geography. So for example, here, with this example, the number of tests of positive for the virus is much larger than the actual number. But we analyze matrices exactly like this when we get satellite images, and then we convert those satellite images into maps. And then we go on the ground and see the category on the ground and compare that to what's the category in the map. So in this case, it's the map that's making the diagnosis, and the truth is what we see on the ground. So we can see this exact same example with some of the work that my colleagues do. So Professor John Rogan is an expert in applied remote sensing. So you can imagine one of Rogan's students using remote sensing to make a map that shows 18% of your neighborhood trees have an invasive beetle. Not unheard of in Massachusetts. Well, our Clark students, because they've taken our class, knows that the map, when they compare the map to what's on the ground, that the map is 90% correct, but also knows that 90% correct can be a remarkably misleading metric, especially because it seems that it's so easily understood. So the student appropriately tells the media that 10% of the neighborhood's trees have the invasive beetle, even when 18% of the map shows that it has the invasive beetle. Boy, so if you look at what's in the table, there's really only 4 numbers, but you have to think about those pretty carefully in order to not make a mistaken claim. Now, this relates to much of my work that's funded by the National Science Foundation, and actually we just submitted another multi-million-dollar grant this year, and National Science Foundation has been funding this site with me and my colleagues at Clark and also at the Marine Biological Lab to analyze land change in the Plum Island ecosystems in northeastern Massachusetts. And we are blessed in Massachusetts to have a phenomenal state agency, MassGIS, who has maps of the entirety of Massachusetts. And so we zoomed in on our particular study area. They have a time series from 1971, and notice, well, the 2 most prominent categories there are green is forest and red is urban. It's urban, it's residential, built up area. And so there's the map of 1971, 1985, 1991, and 1999. So you see a big conversion from forest to residential, and then came the map of 2005. I got the map of 2005, and when that was released, that seemed to show that all of the forest loss during 1971 to 1999 regrew in that 6 years. Like, that threw a wrench into the slogan of the Audubon Society, who was, was giving metrics of forest loss. Well, the reason is that the state used a different method to create the 2005 map than they used to create the previous maps. And so Clark students learned that it is remarkably challenging to make a time series of maps such that the temporal difference in the maps really show the change on the ground. So I'll leave you with this, this brain teaser, which I've heard many times right here in Massachusetts. The environmentalists say that residential development causes most of the deforestation in Massachusetts. Developers claim that they actually try to avoid deforestation and actually prefer to build on agricultural land. Who do you believe? Well, it's possible to believe both simultaneously by looking at a very similar table. So if you see in the rows of this table are the categories at the initial time, and the columns are the categories at the subsequent time. And if you look at the far right column, the sum, you'll see that at the initial time, there's 3 times more forest than there is agriculture. So if developers were developing uniformly across the landscape, you'd expect them to take when they develop, take 3 times more land from forest than from agriculture. But if you look in the built column of time 2, they're only taking twice as much land from forest as they do to agriculture. So this is another of methods that for which we've designed the equations, and now we're designing the software, which we will be very important to incorporate into our new merging Center for Geospatial Technology. But if you want to get a sneak preview at all the equations, you can either register for my class in the fall, or you can learn it immediately by buying the book. I just finished authoring my first book, and now it's available on Springer. So that's, now I'd like to introduce the professors of the HERO program, Professor Deb Martin and John Rogan.
Thank you very much, Gil. My name is John Rogan, and my colleague Deborah Martin and I are going to present briefly on the Human Environment Regional Observatory, or HERO program. This is a program that has been in existence continuously for 23 years at Clark. 2 years from now, we'll be on our quarter-century mark. And some important numbers for you. It began in 1999 with an investment from the John T. O'Connor Fund, and that fund has sustained HERO over the 23 years. It was founded by David Angel, a former president of Clark, of course, and Billy Turner, who was a former faculty member here. And we've mentored approximately 180 undergraduate students in research who start in the summer and then work through the fall and spring. To give you a sense of what we've done over the years, we've worked on projects of social and political importance as they've arisen, and those have varied based on the interests of faculty and students. In the early days, we looked at the drivers and causes of land change in Massachusetts, and Gil was involved at that stage. It evolved to work with National Science Foundation money on lawn care and decision-making in areas around Massachusetts. And with the outbreak of the longhorn beetle infestation in the 2 neighborhoods north of Worcester, Burncoat and Greendale neighborhoods, that was led us down that path to look at the causes and consequences of the invasive beetle. Following that, with the response to the beetle tree removal by the USDA, we focused on a program called Greening the Gateway Cities, which is a program launched by the state and the Department of Conservation and Recreation in Massachusetts. And most recently, we've begun to work with the city of Worcester on their Green Worcester plan. So over time, our interests and challenges have evolved. This is a page from a flyer that we used to promote HERO. And I think what's most interesting about it is the quote we have from one of our HERO fellows right in the middle. Savannah Sanford says, "There is no syllabus for this. This is not like a typical undergraduate research project involving a research paper, and where you can use the internet and lab experiments in class. This was longer and more interactive. We are the researchers, and we're going out collecting the data." So that, from the student's mouth, that's a good representation of what we do.
So, and as Savannah said, we are the researchers. One of the things we wanted to highlight was the ways that students are involved all the way through to including being involved in publications. And in fact, I think I have 6 particular published articles mentioned on this slide, and 3 of them were lead authored by undergraduate students at Clark. So I'm just going to sort of summarize some of the kinds of findings that we've had, and reflecting John's biogeographical expertise and my more sort of social science, urban policy expertise. We look at environmental impacts, and so seeing, even though the longhorn beetle infestation caused all kinds of devastation and real landscape change, particularly in the 2 neighborhoods that John mentions, we actually lose more trees every year based to routine development. So that was one of the findings we had. We also were able to document the way that loss in tree canopy has an actual local impact on local land surface temperatures, and that it can extend the summer warm period. And then on the more sort of social science, urban policy side, we were able to identify the ways that in Worcester, but we argue also elsewhere, ecological vulnerability actually has cycles, and what happens in one cycle and the policy decisions that are made lead to other kinds of vulnerability that need to be adapted to in future. So in the case of Worcester, the classic is that in 1953, there was a big tornado and then they planted a bunch of Norway maples, which were prime location for the infestation of the longhorn beetle. We've also looked at the importance of public-private multi-government collaboration in responding and providing capacity locally for, again, adaptation and response to an ecological crisis like the longhorn beetle, and the ways that risk communication needs to be attentive to different kinds of, the way that stakeholders understand their place risk differently by where they are placed. In terms of the tree planting initiative work that we've done, we've looked a lot at tree survivorship, which is very important. If you're going to spend a lot of money planting trees, those trees need to survive to have an impact. And so some of the most important indicators of survivorship are the degree to which they're stewarded very early. Watering and caring for the trees in the first couple of years are very important, and that itself determines the proportion of the trees that will survive, as does the kind of landowner or the land steward. Having good property, attentive to stewardship plans, particularly on rental property, is incredibly important. We're also able to document the economic impacts of those planted trees, and again, speak to the role of funding and planning for managing an ecological plan that involves not just planting trees, but ensuring their survivorship over time, which means funding for stewardship plans and staff to ensure that those happen. In terms of the other kinds of things that students do, they have all kinds of engagements with stakeholders and policymakers. And so we just want to talk a little bit about, at the end of every summer, the students present their preliminary findings and what they've been working on. And they're usually able to do that to local agencies, government officials, people who are actually involved in policy and who can ask questions that then often lead to new research questions that we pursue in the following year and summer. They also do just basic community work, understanding their partners, like the Worcester Tree Initiative. What kinds of things is the organization doing in the community, and how can they help with those kinds of efforts? So they've been involved in cleanups and tree plantings. They also go to national conferences and present their findings at those conferences. And then finally, again, they engage with the communities in understanding what are the issues and problems. So when you understand what it means to plant a tree well, when you come back 2 years later to see how that tree is doing, which our students do, and measure growth metrics and see how healthy the trees are, they understand some of the what might have happened in those 2 years in terms of whether the tree was properly mulched and not just watered, but whether it was anchored properly against wind and things like that. And then they talk to people. They talk to people who aren't just policymakers, but they talk to people who live in the neighborhoods where trees are planted or trees are being cut down, and they understand sort of the local place identities that are shaped and the communities that they're working in.
Okay, and to follow on, Deb, the importance of engagement isn't possible without the strong partnerships we have with collaborators. And this is a quote from Ruth Seward, who's the former director of the Worcester Tree Initiative. That was the nonprofit that started after the longhorn beetle tree removal, which was enormously successful. Students of the HERO program have conducted valuable research on tree establishment in Worcester and the other gateway cities. Their findings are a meaningful resource for community forestry efforts statewide. And at the state level, this is Matt Cahill, excuse me, who is the former director of Greening the Gateway Cities. The partnership has helped us to analyze changes in microclimates, which has saved us time and money and continues to the benefit of the Greening the Gateway Cities program, which is ongoing. Something that we all know well is that in March 2020, we all had to change our priorities in many ways. And so we were still able to keep HERO going because after 20 years, we didn't want to see it finish or even be delayed. So we were able to leverage the Clark University's forest, which is called the Hadwin Arboretum, and be able to engage with students that summer, socially distanced, masked, outdoors. And again, you see Ruth Seward there from Worcester Tree Initiative helping us plan a planting program there. And it's one of the positives that have come from COVID-19 or maybe the only one really. And so that's just a demonstration of the flexibility that's embedded in HERO as new challenges and opportunities arise. So you may be wondering, where are they now? This is just a snapshot of a few of the HERO students who have been in the program and the years that they were in the program. And you can see from Yanette Ruiz, who is a flood risk assessor in Houston, Texas, to Shannon Palmer, who's assistant principal at Success Academy in Brooklyn, New York. These are students who are now alumni, and we're in contact with a good many of them as well. So with that, we'll stop, and I want to acknowledge that the John T. O'Connor Fund has sustained HERO through the years, but we've also received funding from the George Perkins Marsh Institute, the National Science Foundation, and the Moskowski Institute. And special thanks to these individuals who are listed there, the stakeholders and the partners and the collaborators who have been instrumental in helping us move our program forward. So thank you, and we will pass it on to our colleague, Linda Nestis.
Thank you.
All right, so thanks. Yeah, I'm Linda Nestis. I'm an associate professor in the Graduate School of Geography, and I'm going to talk to you about research that my group does, applying new geospatial technologies to understand agricultural change and its impact. So our work is motivated by the rapid agricultural change that's unfolding in many parts of the world, but particularly in Africa, where we expect food demand to triple by 2050. And meeting that food demand is going to require at least 140 million hectares of new cropland to be developed to meet the demand. Just to put that in context, that's an area that's equal to 1/5 of the lower 48 of the United States. So that large-scale transformation is going to have major socioeconomic and environmental impacts, such as exacerbating the climate change that's already underway, and thereby further increasing the significant weather-related risk that millions of farmers in the region face. So we're interested in understanding what is going to be the exact nature of these impacts, what can be done to minimize the negative environmental impacts, and what can be done to enhance positive outcomes, such as boosting productivity and the resilience of farming systems in the region. So to answer those questions and to find such solutions, we need several critical data sets. Basically, we need accurate maps that are detailed and updated regularly that show us where croplands are located, what the characteristics of the fields are in those croplands, what kind of crops are growing, and what the yields are of those crops. Unfortunately, those data sets really don't exist for most countries at the moment, and so we have to create them. And the only feasible way to create those is by using remote sensing or satellite image analysis. So that presents a problem because we're in this region, most of the farming is still practiced by smallholders. And remote sensing of smallholder agriculture is particularly difficult for a variety of reasons. For one, the types of imagery we typically use does not have the detail or the frequency of collection to reliably detect the small, frequently shifting fields that are common in these systems. And then the characteristics of those fields themselves, which tend to blend in with their surrounding vegetation, confuse the machine learning algorithms that we use to convert imagery into maps. Those algorithms themselves require large amounts of training data that has to basically, or ground truth data that has to be basically examples that we show the algorithm so that they can learn to detect a pattern within the imagery. Such data are very difficult to collect on the ground. It's expensive and they're often error-prone themselves. So the mapping enterprise itself is quite a challenge. Fortunately, there's been several recent technological advances in just the past 5 to 10 years that are rapidly improving our ability to map accurately in these systems. These include the launch of many new satellites that are providing low-cost data that are high resolution and frequently updated. The rising power and falling cost of cloud computing, which you need to handle such large volumes of imagery, and then really rapid increases in the quality and capability of machine learning algorithms, together with growing internet penetration through cell phones that allows you to collect lots of training data for these algorithms. So I'm going to talk to you about 3 projects that we're doing that tries to leverage these advances. One of them is a project in Ghana that tries to improve agricultural extension services. The second is an effort to track long-term agricultural change in Zambia. And the third is an effort to balance conservation interest with agricultural development in Tanzania. So I'll start with the first project. This is a project that's a collaboration between us here at Clark University and Farmerline, which is the lead organization in this project. They're an innovative agricultural technology company and farm services provider based in Ghana. So our project is part of a larger effort called Enabling Crop Analytics at Scale, which is funded by the Gates Foundation and led by Tetra Tech, which is trying to increase the uptake of geospatial technology in smallholder farming systems. So our particular project under this larger umbrella project is trying to basically figure out a way to sustainably create accurate maps of crop types, what crop types are growing in specific fields, and update that annually. And that is information that we can then use to create better extension services for smallholder farmers. So our approach is basically got two main legs to it. One is trying to figure out innovative methods for collecting ground truth data that tells us what crops are growing in what fields in different seasons. The second is then to use that data set, those sets of data, to train advanced machine learning algorithms, which we apply to next generation satellites to try map the crop types themselves. So I just want to first acknowledge that there's quite a significant number of people involved in this. We have our colleagues at Farmerline who are the lead on this, as well as a drone services provider based in Ghana. But I also just want to highlight the many students that are involved here at Clark University from every level of PhD through master's to the undergraduate level. And these students are responsible themselves for developing every part of the mapping workflow, from the image processing through to the really innovative development and application of the machine learning algorithms that we do to do the mapping. I also would like to point out that this involves collaboration with other groups that not mentioned here, such as Clark Labs, that we've been doing this work with for several years now. And funding has come primarily from Tetra Tech, but also initially by Omidyar Network's Property Rights Initiative, now Place, and with computing support provided by Amazon Web Services. So I just want to quickly look at the methods here for you. So we have 2 approaches to collecting the ground truth data. The primary way is through Farmerline's network of extension agents. They use their innovative merge data platform, which is farm management software that they've developed and which Time Magazine actually named as one of the best inventions of 2019. So they go and they work with their network of enrolled farmers, and they go and visit them and collect the boundaries of crop fields there and record what crop is growing in the field. On top of this, we've developed an approach for collecting samples with drone data where we collect near-surface imagery that's got enough detail for us to recognize the crop types within them that extends the range and reach of the data sets we can collect that provides our ground truth. So in the past few months or the last half of 2021, we collected 192 drone images. They're shown there in the blue and red points on the map there in northern and central Ghana, and 5,000 fields visited by agents and their boundaries delineated. So we harmonize those 2 data sets based on where the field agents work and the drones overlap. And then we use that as training data, and that's those blue points there. That's where the areas of overlap. We use those data to train our machine learning algorithms. So this has 2 steps. The first step is an approach that we've developed over the past several years, which allows us to map the boundaries of individual fields at the country scale on an annual basis. This approach is based on deep learning models, convolutional neural networks applied to CubeSat imagery, which is basically small low-cost satellites operated by a company called Planet that collects daily imagery at less than 5-meter resolution, and which allows us to basically create these annually updated maps. So you can see here an example of 3 maps that we've developed for 2018, 2020, and 2021. And you can see that the boundaries of each of the fields are delineated. And if you look at the synthesis of these 3 maps, you can see actually how much these systems are shifting each year. So it's really critical to be able to have a map that's updated on an annual basis to be able to track what's happening in those fields. So that brings us to the second step, which is to actually try and map the crop types in those fields. And to do that, we have another set of models, including a different flavor of convolutional neural network that's designed to work with time series data, which we apply to a different set of satellite data, including the European Space Agency's Sentinel-1 radar imagery. And so we use that to predict what crops are growing within the boundaries of those fields we developed in the previous step. And this is an example here where we have predictions for maize, rice, and other crops. So now that's data that FarmerLine is using to develop a whole bunch of enhanced knowledge and services for smallholder farmers and the businesses that serve them. For example, knowing where specific crop types are growing in which regions enables FarmerLine to provide more tailored advice to farmers. For example, what seed varieties they should use and how much fertilizer they should apply to them. Similarly, they can also tell agribusinesses that are basically distributing these seeds and fertilizers where they should, distribute their efforts more effectively. So this is hopefully information that is going to improve the outcomes and productivity for smallholder farmers. So that's one project. The second project I want to talk about quickly is our efforts in Zambia to track long-term agricultural change. Zambia is a country that's been undergoing some of the most rapid agricultural expansion in Africa. So we're interested in understanding what is the impact of that agricultural growth. And we eventually want to use it to understand how yield trends are evolving. Is productivity increasing? Is it becoming more sensitive to climate change and climate variability? And questions like that. So this is part of projects that have been funded by NASA and the National Science Foundation for several years. And so a first step in this project is being able to simply create a map to show how the agriculture has changed in those 20-year time periods. So to do that, to create those sets of maps, we're using long-term time series based on NASA's Landsat satellite together with radar. And we've developed a probabilistic mapping approach that's implemented in Google's Earth Engine platform, which is a cloud computing platform that's become widely used in the past few years and is really revolutionizing how remote sensing analyses are being done. So we've done that to detect where the croplands are in the year it's expanded in. And the result is this map that you see here, which is all of Zambia. This has just been produced. And it shows us where cropland is expanded from each year between 2000 and 2015. And you can see the year in which a new field was made by the color coding in those insets. I'd like to flag that this is work that has been led by a PhD student here, Sitian Shung, is in geography, as well as by a recent master's in GIS graduate, Priscilla Baltazar. And what's also quite special about this work is that they've initiated and sustained a collaboration with McGill University to do this work. So I'd like to flag that as an important achievement as well in its own right. So this map provides us with the base that we need to understand that long-term agricultural change in Zambia. Finally, I'm going to talk to you about a third project here, which is led by Lei Song, a graduate student, a PhD student in geography, also using funding from a NASA fellowship. This is focused on Tanzania, and the objective is to understand really how elephants are moving and using the landscape in Tanzania and how they're moving between agricultural areas and natural habitats. And so this is in order to basically provide or offer solutions that can be used to help with things like land use planning. How do you better balance where agriculture and conservation lands are placed by understanding how elephants need to use and migrate between habitats? So the approach for this starts with developing a high-resolution land cover map, which is then used as the basis for studying elephant movements within the larger landscape. So this is the first work that Lei's just produced. It's a really quite a remarkable achievement. This is a countrywide map of Tanzania, which I believe is 4 times the size of Texas at 5-meter resolution, showing all the major land cover types, particularly where cropland is in relation to other natural habitats. And so this was developed again using an innovative deep learning approach together with CubeSat imagery, and now provides the foundation for that movement, elephant movement analysis. So I'm going to stop there, and I just hope that these examples give you a sense of the type of real revolution that's happening in geospatial analytical capabilities at the moment, and how we're using them here at Clark to improve our understanding of how agricultural change and other types of land change processes are happening. So I'll turn it over to my colleague Karen Fry now. Thanks.
Thank you. That was great. Thank you to my colleagues so far. My name is Karen Fry. I am also in the Graduate School of Geography. I've been here since 2007. I've had the great fortune to have all sorts of different projects funded by all sorts of different sources, but even greater fortune to have worked with some really incredible students along the way, undergraduates, master's students, PhD students, many of which you can see here. Many of the pictures that you see here are students that have gone on to be professors of earth science, of geography, of environmental science. We have a diversity, equity, and inclusion of STEM at UMass Amherst in these pictures. We have many GIS analysts at NASA, at the Environmental Defense Fund, at all sorts of different consulting agencies. So we've been really, really fortunate to have some really incredible students that have helped to develop polar research at Clark in particular. So if you were to look at all of the work that has come out of our lab since I've been here, and if you were to look at all of the keywords of all of the work along the way, they tend to fall out in three different lobes, if you will, of my particular research. We have sea ice in Arctic marine ecosystems, glacier, ice sheets, and snowmelt dynamics in terrestrial realms, and then the biogeochemistry of permafrost environments, which is basically perennially frozen soil. A lot of this work has been across Siberia, as you can see in the maps in the upper left-hand corner, also in Greenland, in the North Slope of Alaska, and also in Antarctica. In terms of methods, my work is sort of at the triple point of field observations, modeling, and also remote sensing and geospatial analysis. For this particular talk, we're sort of focused on the remote sensing GIS analysis side of things, so I'll sort of keep my examples to that side of things. But we really kind of are at the nexus of all three of these methodologies along the way. And we have had students from Clark go to places in all of the stars that you see there. We've had students do field work on ice sheets in Greenland and Antarctica. We've had students, numerous students, go to the peatlands of Siberia. Most recently, we've had students come along to do field work with me on icebreakers. This coming summer, I have 2 students coming with me on a Canadian icebreaker that will be up in the Bering and the Chukchi Sea surrounding Alaska. So why do we study these areas in the first place? If you look at the green line there, that basically is what global temperatures have done since pre-industrial, since the late 1800s. If you look at the blue line, that basically is what Arctic latitudes have done. And for a long time, we sort of had the basic byline that Arctic temperatures are warming twice as fast as sort of global averages. But it turns out, if you look at sort of more recent research, it turns out that Arctic latitudes are actually warming up to 4 times faster than the global average, due to all sorts of different things, primarily due to the fact that we are replacing some of the brightest things on the planet, such as snow and ice. And we're replacing that with some of the darkest things on the planet, such as dark forests and ocean surfaces. So it's always great to kind of see these line plots, but always, obviously, as a geographer, we're very interested in understanding the spatial variability of these changes as well. So obviously, you can see the animation on the right kind of giving you a sense of really how important these high latitudes are for overall climate change. So just kind of focusing on one of those lobes of research, here I'm just going to show a couple different examples as it relates specifically to sea ice ecosystems. We do a lot of field work, and so it's really important to kind of get our boots on the ground to understand what's going on at these particular locations. You can see on the left a sort of a primary example of what sea ice might look like in March in the Bering Sea. So very bright white, very high albedo, very reflective surfaces. This is sort of a day when I went out off the ship and had my eyelashes frozen closed. It's very, very cold and very windy. On the right, however, as you sort of start to see that sea ice start to melt back, you can see that those bright surfaces really get replaced by some of the darkest things on the planet, which in this case is ocean water. So very, very important in terms of the sensitivity of overall climate with these high latitude environments. With these field opportunities, you can only be in one place at one time. Right, so you're really important for calibrating things, really important for validating and sort of really understanding what our remote sensing satellite imagery is telling us. But you do have certain limitations in terms of, as I said, being in one place at one time. Sort of as we start to incorporate satellite imagery, we can really get a sense of sort of what the overarching trends seem to be. And in terms of sea ice decline, when we look at the seasonal minimum of sea ice in the Arctic, this essentially is what the trend has looked like based on satellite imagery. And so you can see these particular satellite time series were started in the late 1970s. You can certainly see that we've had some really interesting sort of anomalous lows over the last several years. The current sort of record is 2012. 2020 was also a relatively low year that almost beat out 2007, which was a really big tipping point in these particular observations. But if you look at trends over time, we essentially have lost overall about 81,000 square kilometers per year, which may not sound like a whole lot, but if you think about that contextually, it's about losing the size of the state of South Carolina per year. The Arctic is not a huge place. So think about basically the state of South Carolina being removed, one of those being removed every single year over the last 42 years of our satellite record. And you can kind of get a sense of what the spatial variability of that looked like as well. In the red line, you can see that's the 1981 to 2010 average seasonal minimum versus what 2020 did. So the loss of Arctic sea ice is really critical in all sorts of different ways. As I said, in terms of these field observations, you can only be in one place at one time, but really critical for understanding and interpreting these satellite images in the first place. So if I were to take you with me all the way up to the Arctic, put you on a ship, dock that ship up against a really big, nice, sturdy sea ice floe and walk off that ship, as we do, and basically stand on top of that sea ice, on top of perhaps 4,000 meters of ocean water beneath you. This essentially is what you would find. So I've taken a GoPro camera and just sort of attached it to my instrumentation, and I've let it through the sea ice surface, as you see here, letting things just go hand over hand over hand. If you could look closely, you can actually see my hand through that hole there. But as you're looking at things, you start to see some really remarkable patterns of what light transmittance does through the sea ice surface. And as it turns out, melt ponds, and as the sea ice starts to melt back, matters tremendously for the amount of light that is actually available in the ocean in the first place. And so, for instance, if you were to look at the sea ice at the top there, you can kind of get a sense of what those melt ponds look like. They're very dark. And as it turns out, because of the low albedo and the sort of the high absorption of that surface in terms of the melting, it actually takes that light and allows that light to transmit through the sea ice surface. So if you look at that sea ice from below, what you see essentially is the photographic negative of what you're seeing from above. So in other words, because of the low albedo and the high transmittance of light through there, these melt ponds that you're seeing basically act as skylights. And in a case where we didn't have these melt ponds, you might only let 10% of light through. In the case of increased melting, and in the severe case of decline of ice altogether, these melt ponds can actually let up to 70 or 80% of incident light through these sea ice surfaces. So really, really important for generating heat, for sort of allowing things like photosynthesis to occur in the water, among other things along the way. So we can take those types of hypotheses that we place to kind of get a sense of, first of all, what is sea ice doing across the region? So these are our particular field sites that you see here on the left. And that's using sort of spatial analysis to have a sense of how fast sea ice decline in these areas is actually occurring. And so the deeper reds are indicating a stronger decline of sea ice. The cool colors are denoting increases in sea ice. You don't see a whole lot of those cooler colors by any means. But in those really deep areas of red, this is a 20-year record. So per decade, we're losing up to about 60 days of sea ice cover per year, which means over the 20-year time series, we're losing 120 days or 4 months of sea ice cover. So it's massively changing, not only the physical systems of these areas, but the ecosystems that rely on these physical environments in the first place. We can also sort of use, for instance, not only sort of the observations of sea ice, but we can actually look at the color of the ocean water as well to tell us something about what is going on in terms of photosynthesis. You've probably heard a lot of my colleagues today at this session and others talk about the importance of terrestrial ecosystems. But when we think about photosynthesis across the planet, terrestrial ecosystems are only 50% of photosynthesis on the planet. Ocean ecosystems and ocean photosynthesis make up 50% of the other sort of side of the story. So really, really important in terms of understanding how carbon is moving across the planet, how we might mitigate climate change in terms of geoengineering applications, all sorts of different things, but we can't forget about the importance of oceans. So we use these sort of types of colors of the ocean to tell us something about what chlorophyll concentrations and therefore things like primary productivity are doing in our oceans as well. So this is sort of just an example of sort of the low end of the food web, which is incredibly important. Some of the most productive marine ecosystems in the world occur in these Arctic areas. So we can take those satellite images and tell us something about how much grams of carbon we're actually sequestering and how that's changing over time. Here you obviously increases in photosynthesis and in primary productivity over time, which of course has some really severe, dire consequences in terms of shifts in ecosystems that I'm certainly happy to get into more if people have questions sort of in the Q&A. But really the beauty of being able to have these satellite images and time series is it really gives us a holistic perspective of what's going on across the region. We can start to sort of look at how the mean open water season is sort of related to annual primary productivity and to sort of see at our particular sites kind of which is most intimately tied to these particular drivers of sea ice decline to get a sense of whether it's sea ice that's limiting productivity or whether it's things like nutrients and things like that, which are also very, very important. That's an example sort of on the lower end of the food chain. In terms of upper trophics, we have also had some really sort of interesting research projects looking at with sea ice on a much higher spatial scale as well. What you're seeing on the left is an image of Landsat, which is sort of something that all of my colleagues have worked with, and Lyndon in particular talked about as well. But each pixel being sort of 30 meters of area gives us a really clear indication of the shape and morphology of those individual sea ice flows, something that you might not be able to get at with lower spatial resolution data. This is a picture that I sort of took up in the Bering Sea, but really kind of gives an indication of the type of accuracy that we have with being able to classify those sea ice flows as well. And as it turns out, in terms of getting a sense of the size and the shape and the distribution and the morphology of those individual sea ice flows can tell us an awful lot about the importance and the overall health of sort of larger mammals and the upper trophics in the area, such as the Pacific walrus, which was actually petitioned as a threatened species under the Endangered Species Act that unfortunately was not approved with the Trump administration, but still a really, really sort of important species that has had some really dire impacts from the loss of sea ice decline along the way. This was a project that was actually undertaken in collaboration with myself and Florencia Sangermano, who's also a professor in the department, but led by Anthony Himmelberger, who is a undergraduate, actually, and a fifth-year graduate from Clark. But he, in collaboration, we've just gotten this paper published, as with Anthony as a first author, which we're really proud of, but really kind of shows the ability of using sort of other methodologies, not necessarily from oceanography that I have learned from my colleagues along the way, to apply in really novel ways. So for instance, we have used methodologies from the landscape ecology field, trying to understand kind of the shape and the overall morphology of these sea ice flows from the field of looking at sort of landscape fragmentation and landscape sort of habitats and ecosystems. And the beauty of geography is probably clearly one of the most interdisciplinary fields that I can certainly think of, is that I'm constantly learning from my colleagues, constantly learning sort of new methodologies to apply in a really novel new way. And in particular, sort of understanding the morphology and the shape of these sea ice flows, which was originally sort of coming from this landscape ecology field, really kind of gave us an ability to kind of get a sense of, with sea ice coverage and as sea ice coverage going down, how are the shapes of these flows going to change? And as it turns out, as sea ice declines, these sea ice flows actually become rounder, which, as it turns out, is kind of detrimental to walrus because they actually prefer much more broken pack, much more sort of angular types of sea ice flows. And so this is really sort of important contribution to kind of understanding the future fate of Pacific walrus as it relates to sea ice as being a really important part of their overall habitat. And again, thanks to the constant learning that I have from my colleagues, sort of understanding these different types of methodologies to be able to apply in a field such as oceanography was a real sort of benefit, I think, in terms of working with people that I wouldn't have had I been in, for instance, an earth science department or an oceanography department that's much more streamlined in terms of overall fields. So with that, I just wanted to sort of give a couple examples, and I will leave you all with this photo of some milk ponds. So thank you.
Well, we designed this to have plenty of time for questions. So or comments. We're very much interested in your feedback. Or if you want to add something or have a question, we are here to open the discussion with you. Who's going to be first? And we have someone with a microphone, right? You can raise your hand and you will be delivered a microphone. Yes.
Hello, my name is Omesa. Thank you so much all for the wonderful presentations. I'm particularly interested in the presentation with like agricultural change in Africa. So I was intrigued by the fact that almost a third of the world's arable land is in Africa, yet Africa suffers most from food insecurity, which is so kind of paradoxical for me. And with all this research that you're doing, so I'm interested in knowing who are the consumers of the findings and the data you know, with all the research that you're doing. Does it get to do you work with the policymakers, or does it get to the hands of the policymakers? Because you've seen a case of like siloed approach in doing all this, where scientists do the work, but the findings don't get to the people who need to use them to effect change where it's supposed to be used. Yeah, so like, do you work in communities with policymakers in co-creating solutions for some of these issues that you are talking about coming about due to climate change?
Sure. Thanks for the question. Yeah, so I can answer that question in a couple parts. So the first project I mentioned with respect to in Ghana, that's information that's being directly used by Farmerline, which is an agricultural services provider. So they're turning it into the products that are going to serve their customers most effectively. So that, to me, is perhaps the most one of the most direct ways that the information can benefit. And so they're turning it into the types of information that they think will be most effective. From another standpoint, though, the projects, almost all the projects that I mentioned, are mandated to make the data and the methods open. So all the data sets that we're collecting and making the maps are publicly available, and they have multiple purposes. You know, the maps themselves can be used by policymakers. The better agricultural maps provide you information that can be used to, by statistical agencies in different governments to make improved estimates of crop production, for one. A big part of what we do is try to collect better training data sets for machine learning algorithms that are then made public, that can be used with the goal of making them be usable by all sorts of interested parties that are trying to develop improved services and geospatial applications for agriculture. And that's one of the big purposes of that enabling crop analytics at scale project I mentioned. So yes, all of these things are intended to be open, freely available, and to inform policy, or I should say end users. And it's a diversity of end users.
Okay, well, we have other questions, comments?
Hi, Karen. Nathan, fellow oceanographer. So I was going to ask you about your work with the melt ponds. Is there, I can imagine there might be a feedback loop of more light being available for the phytoplankton and then shielding the light from that growth response. Is something you've looked at, and is, yeah, curious to hear about that.
Yeah, so there are certainly interesting situations where you get so much growth of algae in the ocean such that it shades shades area deeper in the water column. So even if there are nutrients available, there's not enough light to certainly support that photosynthesis in the first place. One of the bigger sort of challenges in these areas is that in these areas, not only do you have ecosystems in the water column itself, but you also have really important benthic ecosystems as well at the seafloor. And because these areas are very, very shallow, the video that I showed you, that might have been 4,000 meters of water, but over many of these sort of shelf areas, it's really only 30, 40 meters of ocean water. So at the top, it may look like this expansive ocean, but they're really, really shallow. And what that means is that the sort of carbon that gets produced sort of above can also really importantly feed these benthic ecosystems. So I'm sure you all are aware of like deadliest catch and thinking about all of the sort of the king crab that live in these areas. I mean, it's a massive amount of sort of biomass that lives in these areas. And as it turns out, sea ice and the algae that is associated with sea ice specifically is very fatty. It's very lipid rich. It's very heavy. And so, you know, in the early part of the season, if you have a lot of sea ice, all of that sort of sea ice algae is really important for the benthic ecosystems because it drops fast, it's heavy, it's very fatty, right? It feeds all of the benthic ecosystems down there. But with the absence of sea ice and the decline of sea ice algae, those benthic ecosystems are starting to be starved. And so while the water column sort of might be, you know, might be seeing some changes, it's really the benthic ecosystems that are sort of seeing the biggest changes over time. So that's a massive issue for fisheries, certainly from an economic standpoint, but also from a standpoint of walrus. You may not know, but walrus are actually a benthic feeding mammal. So they actually will dive to the bottom of the ocean. They'll dive down those 30 and 40 meters. They'll take a big you know, scoop full of mud, and they're after the clams and mussels and all of that sort of embedded in the mud. And so not only sort of are we worried about the water column, but also the benthic ecosystems as well, which has really sort of cascading influences based on that. So thank you.
Thank you very much for a fascinating presentations. I'm Sebastián Rollo, I'm the provost, and I have a question. You have presented fact-based evidence of what is happening in the planet and the very negative consequences that it's having. But there's still quite a bit of a skepticism out there, and people that don't quite believe this. How do we turn the tide? How do we convince people of the evidence that you presented to us? Easy question.
I'll just share my perspective on this. In my field, I see people scientists using metrics that are completely inappropriate and that make no sense. And so I published a paper that was extremely critical of this one particular metric called kappa. And it turned out to be my most highly cited paper. And then I started reading the people who cited it. And these other scientists said, we used kappa and cited my paper that's entitled Death to Kappa. And so, I mean, if I can't have an influence on my other scientific colleagues who have university degrees and who are publishing in journal articles, I mean, to convince other people on the street that they should be concerned about climate change, I don't know, you ask a very important question, but that just gives like my baseline, you know, of how difficult it is to change people's attitudes and habits. So I don't know if my colleagues have a different approach.
I'll say something that isn't an answer as a solution, but one of the papers that was up on one of the slides when John and I were talking with the lead author of Hirsch, Joey Hirsch, who was an undergrad geography major and was a Hero Fellow. He was really interested in the long tradition at Clark of risk communication and risk hazards research, which is an area in geography that, as I say, has a long tradition at Clark. And he took some of our work looking at how people understand sort of their immediate circumstance. When we looked at the longhorn beetle infestation, one of the dynamics on the sort of the social science side of things was the ways in which people respond because their backyard no longer has squirrels in it because the trees were cut down, or people don't want to hang out on the street anymore in the summer because the trees were cut down, right? And he combined this kind of finding that's very anecdotal and experiential and looked at risk communication, which argued, and then applied it more broadly to the forest product industry in Worcester County, the residential response in city of Worcester and the two neighborhoods that John mentioned, and the city and state response to the longhorn beetle infestation, and argued that you really have to give people motivation and understanding based on their, what in my side of geography we call their relational place, their local place understanding. And so you have to explain what's happening. I mean, people might think walruses are cute or impressive, but until they're able to kind of connect it to what does it mean in my backyard, unfortunately, that's kind of how oriented we are, that if we can situate their own place experience with changes going on, that a lot of it is about communication, which is not any of our expertise, but and there is a special area called risk communication, which is engaged in by geographers, but also other folks in other disciplines, which I think it's about reaching people with what their reference point is.
Well, I would like to thank all of you for attending, and let's give a round of applause to our presenters, Deb Martin, John Rogan, Linda Nestis, Karen Fry.
And Gil Pontius.
Thank you. So we look forward to interacting with you either immediately after this session, I know I'll be around, or at other events during these wonderful festivities of the inauguration of our new president. Thank you for coming.
Thanks, Deb.
Good afternoon, everyone. I'm Esther Jones, a faculty member in the English department and currently serving as Associate Provost and Dean of the Faculty. And it is my privilege to welcome you to one of the final events of President Fithian's inauguration academic symposium on medical humanities and aging. For those new to the concept of the medical humanities, this is an interdisciplinary field and intellectual framework that applies a multidisciplinary approach to critical issues in medicine and health. This approach aims to foster a better understanding of what it is to be human, well, ill, and to experience the healthcare system through the fields of humanities, arts, and humanistic-leaning social sciences. We have an exciting opportunity to hear three outstanding members of our faculty from psychology, photography, and documentary filmmaking or screen studies who will engage in an interdisciplinary dialogue about aging and later life. A quick note about the format of this panel. I will first introduce my distinguished colleagues. We will then watch the first 14 minutes and 30 seconds of the award-winning documentary With Dad, in which Soren Sorensen, our faculty member in Visual and Performing Arts, Screen Studies, chronicles photographer Stephen Dorado's photographic documentation. See how meta that gets right there? Photographic documentation of his own father's experience of Alzheimer's disease. And we will then engage in a cross-disciplinary dialogue about aging and later life, and what it means for a society of increasingly healthy and growing population of older people. First, Stephen Dorado is an award-winning professor of the practice of photography in the studio art program here in the Department of Visual and Performing Arts. In his more than 40-year career, he has been the recipient of numerous awards for his work, including the prestigious John Simon Guggenheim Fellowship, a total of 5 awards from the Massachusetts Cultural Council and Massachusetts Art Foundation Fellowships, and has most recently received a Diane Fund Award to support the publication of his forthcoming book, also titled With Dad. Soren Sorensen is an associate teaching professor in the Department of Visual and Performing Arts and the Screen Studies program, and an award-winning documentary filmmaker. The short documentary With Dad, which we will see the first 15 minutes of, has received several awards from various film festivals in the Best Short Documentary category. His forthcoming feature-length film, Omar Sosa's 88 Well-Tuned Drums, had its world premiere this past Saturday, April 23rd, at the 52nd Annual USA Film Festival in Dallas, Texas. The film is a look at the life and work of Grammy-nominated pianist and composer Omar Sosa. Finally, last but not least, I'm pleased to introduce Jeffrey Arnett, a senior research scholar in the Department of Psychology at Clark University. He is the leading authority in the world on the age period from 18 to 29, which he coined emerging adulthood. Dr. Arnett is the founding president and executive director of the Society for the Study of Emerging Adulthood. His most recent research interests have turned to the age period from 60 to 75, as he considers later life from a developmental psychology standpoint. So again, to frame our dialogue with my esteemed colleagues, we will begin with the viewing of the first 14 minutes and 30 seconds, we timed it, of Sorensen's documentary With Dad. Again, a documentary which engages Stephen Dorado's photographic documentation of his father's life and experience with Alzheimer's. After the viewing of the beginning of the documentary, we'll then engage the panelists in a dialogue and open up the conversation to you, our audience, for thoughts, conversation, and further discussion. So without further ado, with Dad.
Here he comes. Here he comes. Hi, Dad. Let's take a look at you.
Yeah, you know, it hadn't even occurred to me, but that isn't an unreasonable. Oh, you're welcome. Oh, good. Friday the 13th today, and Valentine's Day tomorrow. Groundhog Day last week.
You feeling okay? Dad, you feeling okay? Hey, you know, it's almost spring, another month to go. Valentine's Day tomorrow. Ash Wednesday in a few weeks. Hey, have your eyes open? Huh? Huh? You have a little bit of life in you? You're always sleeping on me lately. It's the winter, right? We're hibernating. I have to back up. I grew up in a wonderful family, very supportive of my early inklings of becoming an artist. My father, Gene Dorado, worked for the state of Massachusetts as an artist. If you grew up in Massachusetts, you went up to Boston Globe and there was an artist rendering of a building, of a person, of a highway going in, you saw Gene Dorado's work. Engraving a house with an art like that is that, of course, my father was my mentor. And not only did I see him paint, draw, and photograph for his work, but he also brought me to museums at a very young age. And he taught me how to draw and paint. But I always was very interested in his camera. He always used the camera to make notes with, to photograph people for portraits, which he eventually then transferred to paint or to charcoal. And one of the great things that I loved about my father when I was very young is that he photographed gatherings during the holidays. And I really thought that was as good as it gets. And I asked him maybe at around 10 or 11 years old, Dad, can I borrow your camera? And he would say, kid, that's the bottom of the food chain. You don't want to be involved with photography. Pick up the pencil, pick up the brush, even better, become an architect. And finally, I wore him down after a couple of years of pleading with him, begging with him, and he loaned me one of his cameras. And so this particular shot, 1972, Easter, I got permission to photograph the family. Here again, my father and his other siblings. This is actually a photo I made at my grandmother's funeral, their mother's funeral. And the thing is that I photographed all my family all the time, unobstructed, uncensored. And that I knew very early on was an amazing gift to me, an ode to love from the family. Here's a formal portrait of my mother and father in their living room. It was about fashion, the goatee, my mother's bell bottoms that she's wearing, and again, the decor, what you see around them. And also notice that the family is surrounded by family photos. Here's an example of going to the beach. My father loved going to the beach my entire life. It was nothing for him to call in sick on a Monday morning when he found out it was going to be 80 degrees and clear. And in the car we went, and we were at a number of beaches up and down the New England coast. And I'm bringing my big box camera with me, and again, documenting the family. You know, it's kind of an honor to do this, to do any of this. Photograph Dad, photograph on the streets, shoot at dinner. You know, we don't even know if this is totally legal what I'm doing in the nursing home. And if
fact that everybody there kind of turns their head to the left and to the right just a bit, knowing exactly what this is all about, which is also an amazing thing.
Alzheimer's was in the news at this point. Drugs being introduced, our generations of family and friends are growing older and living longer, and Alzheimer's is becoming the thing that everybody's talking about. And I was afraid that maybe something like this is happening to my father. And there was just something about him that seemed a bit reserved and removed, and even the possibility of him being a little depressed. And it worried me because I really wanted him to go on to become the artist that he talked about all his life, somebody independent, but I felt I needed to make an appointment. I needed to just be with him and nobody else. And this is the very first time that I did this particular October day. I went home, developed a negative, printed it, and looked at it for a while and thought, all right, this is going to be routine for as far as we can take it and see what's going on with my father. He's about 60 years old at this point. I'm 60 years old at this point right now. And so, of course, I reflect on where he was at. The conversations are short. They're yes and they're no or maybes. And that he's not really inquisitive about what I'm doing. And I should bring forth that earlier in my career, that he was by my side, that he was in my studio and he was critiquing my work. And he was telling me what worked and what didn't work and what might be sellable, what might be more of a fine art project. But there was a detachment that was very unnerving. This photo here even changes things for the worse. And I got a call, an emergency call, that Dad had a stroke. And I brought my camera. It's what I do. But a lot of my photos that I include myself, I use a cable release that is connected to a squeeze ball rubber little ball that you squeeze, and the air jets through it, hammering on the shutter release of the camera to have it fire off. And so a lot of the photos that you see with me included in them is that I'm triggering the camera that particular way. So in this shot here, I asked my father to look at the camera, and he's well enough to do this, to understand that looking at the camera is what I want him to do. Before I made this photo, I asked him a simple question to count to 10. And he laughed and he said, absolutely. And he went 1, 2, 3, 4, 6. You know what? I'm not going to do this. That's below me. This is ridiculous. It's absurd. Even more so now than ever before, I'm very concerned about my father. Will he fully recover from the stroke? He can't count to 10. There's a lot of stuff going on here. My appointments with him are picking up. They're now no longer a few months. They're every few weeks. And I find myself touching him and holding him and hugging him. It's the only way I know how to communicate. And so what you see here is I'm sharing this breakfast table in the kitchen with him and really showing you that we look alike. It really is reference to the hands and how similar my hands are to my father. This is right outside of Palm Beach. It's Boynton Beach, Florida. And my mother and father have been going there for, I think at this point, at least 30 years. So here he is in the carport, standing by the door to get into the house. And while we were talking, my mother pulled into the carport with her headlights on. And it illuminated my father in a way that I thought very much like those early great horror films, Frankenstein and Dracula. The light was coming from some unearthly point of view. And it really hit me on an emotional level that he was my father, but he was also a stranger. Chris, I'm going to actually have you participate. I'm going to have you pick up the sun up in here, like this, so that you hit Mom from there, from that angle.
You want me to hold it?
Yeah, see how it's just hitting Mom like that? Just hitting her face from the side. Just a little bit. She's going to pick up a little more.
Oh, okay.
There it is.
There it is. Perfect. All right, 60 it is. Thank you. Perfect. And, hey, Mom, just looking right at the camera. There you go. Stay very still. 1, 2, and good. We're done.
It's like taking X-rays.
Isn't it something? Good. That's it. This is 1 year later, also at Boynton Beach in Florida. My father's no longer at the center of the table. My mother's replaced him. She's the matriarch, and my brother and myself in the frame on the right-hand side. What we're doing here is we're acknowledging the camera like it's a friend or a family member walking into the room. Bit of a stretch at this point because he's becoming very distracted. And he's got a mind of about a 3 or 4-year-old. very close to my brother and sister. I'm the eldest, by the way. We decided that we would rotate our weekends and that we would daddy sit, that we'd go and spend 3 days with him, Friday, Saturday, and Sunday, cook for him, take him out for rides, watch TV with him, play some music. We also isolated him in not the master bedroom, but actually in my bedroom, in the children's bedroom. Because at this point, he was having accidents. He was waking up 3 in the morning. He was disoriented. He would urinate against the wall. We removed all the rugs. We pushed the furniture back. We gave him just a single bed to sleep in. And so here he is in this room, isolated. And I'm going to point out on both sides of this frame are photos of mine. And I found that incredibly sad that here he is isolated against this wall, almost like a prison room. And the family, again, is disappearing, is moving off to the edges. You know, I have plenty of time on my hands to make these photos. There's not a lot of stuff happening fast here. We're talking hours and hours of silence. You know, negotiating food. It was not easy for him to even eat food at this point. A number of times he's motioned to me after I put like a chicken breast in his plate with fork and knife nearby with him to motion that he can't eat it. And it didn't take long for me that I had to cut it up for him. What you might not notice in this photo is that he's missing his eyebrows, because when he'd go in to shave, he wouldn't stop with the beard, that he'd continue starting to shave his head and his eyebrows. And I set him up and he's eating his chicken and whatever green that we have in here. And I said to him, "Dad, would you like seconds?" And he didn't say anything. He just kind of looked at me. And I said, "I think you want seconds." And I put another chicken breast in his plate. And when I turned away to get myself a drink, the chicken breast ended up being thrown into my face, hitting the side of my head. And I realized that was his way of saying he didn't want to have seconds. And every half hour, 40 minutes at best, he'd get up and walk to the bathroom. And he'd come out 10 minutes later and he'd sit down. And this went on all day. And I said to him, "Are you okay?" And he said, "Yes, I'm fine." I said, "You know what? Next time you go into the bathroom, I'm going to follow you in with my camera." Fine. Sure enough, 15, 20 minutes later, he gets up. I follow him in with my camera. You have to remember, this is about 30 pounds worth of equipment. And he's looking at the mirror. And I'm like, "Dad, you know the deal. On a count of 3, I'm going to make the photo. Stay very still." And I set up the camera. I got the shutter release in my hand. And I'm like, "Dad, here we go. 1, 2. And before I got to 3, he turned around and he smiled for the camera. And I said, no, Dad, look in the mirror." And he looked at me and he said, "The man in the mirror is looking at you." And I realized how bad this really was at this point, that he lost sense of self. He didn't know who he was. And it was a moment of, am I exploiting my father for my own purposes? Is this going anywhere? Is it going to be in any way helpful for others to see where this is going to go from this point on? And I looked at my father and I said, "Dad, what do we think about the man in the mirror?" And he said to me, "I like that man." And I said to him, "I love that man. And I think we both need to look at that man in the mirror." And I got him to turn around and look at the mirror. And I made this photo. It gets worse, but then it gets better at the end. I just want to let you know, okay?
So quickly, for those of you who have not seen the full 30-minute documentary, it is available to watch free online at wgbh.org. And it's certainly a compelling documentary that we would encourage you to view, the complete documentary in its entirety. But there's a riches here of themes and topics that we could explore. But I just want to take a minute to kind of frame a couple of questions that I've shared with Jeff and Stephen and Soren in advance, and to kind of use as a jumping point for us to kind of think about some of the themes in the film. So you've got documentary filmmaking, and you've got this notion of framing and frames, and how we frame later life, how we frame aging, how we frame, and framing is a way of understanding, right? So if we're gonna have a conversation a little bit about time, aging, and reframing later life, so the different levels of framing that are happening here. So Stephen, Soren, as you all are kind of thinking about this framing, the documentation of the decline, this decline that you've documented over time, a lot of time, right? Spent with this. What can you answer that question that you
I
posed,
think
right?
about it all the time.
At the end of that,
Yeah,
right?
I think of it all the time. Not always through my camera, even though those of you who know me, that if you take this away, I'll die. But so, you know, I watch you. I'm watching you right now going, wow, there's a photo here. But by watching everything in my life and studying, you know, that big family that you saw, I watched all of them. I studied my family. I could not articulate what they did growing up. So I was the quiet one. But I had a great party in my head watching the psychodramas. And, you know, I'm going to talk, somebody told me once about layers, and maybe the layers of an onion. And the fact is that when your grandparents go one by one, that those layers get thinner, and how frightening it is. But you always have your mother and father, or a parent that's close by that still protects you. And there was a point when my father was ailing that I realized that there wasn't much protection left. And I had to rethink my role. I was no longer a child, even at 40 years old, but I was becoming the parent, and that I had to be responsible for that. And I know for a fact when that hit me, that I was comfortable for that and working in reverse, that I was the one that had the words of wisdom. I was the one that was best for them as opposed to them being best for me. Is this kind of answering some of the thoughts that you've had? And then, of course, you know, the film itself explains other things going on in my head, because I had to change my role constantly. And I was caretaker, feeding him and washing him. And I think some of you are way too young and you think, I could never do this. Guess what? You can do this. You really can. And you know, Bob, I'm looking you out there, who you're my hero, because you recently did this. I'm very, very proud of you, losing a parent. And it's a gift. You give back. They gave everything to you, and you give them something back. So.
Yeah. Soren, can you talk a little bit about how you chose to frame this narrative of this person who's documenting his father's kind of long decline? Talk a little bit about your documentary practice there.
Yeah, absolutely. I mean, when you say the word framing, I can't help but just think in filmmaking terms. Like, I get that it's broader than that, but I'm thinking about what's in, like, what we're seeing, what we're not seeing. So framing, right? But you know, there's also this photographer who has these hundreds of pictures over this 20-year, you know, course of this 20-year event that happened, and he's thinking like a filmmaker in some ways too. So when I'm looking at, you know, these photographs, I'm seeing filmmaking techniques, or I'm seeing the way that he's choosing what's in the frame and what's not in the frame. So the photographs are done. Like, I can choose what goes in and what stays out. But in a way, like, then the question is, well, what do I want the interview to look like, and what do I want, what do I want in, what do I want out? And so this whole idea of like having Stephen be against the black backdrop and just this really kind of, you know, naked kind of frame. There's not much going on there. And in fact, this was shot in this building in 2018, that interview in a classroom on the 3rd floor where I teach. And we just built a black box out of duvetine and paper. I mean, it's just, you know, kind of sound blankets and C-stands and stuff. And he spoke to a lens, in fact. It's not like he was speaking to me. He was speaking into a lens, and I knew he could do it because he's been looking into his own lens for a long time. So yeah, it was. So when you say framing, it's always about like what's going to go in, what's going to stay out, and how do you do that without overthinking it. And you do it by touch, you do it by feel, and hope that, you know, you're honoring what Stephen's doing. If I did my job in this, like, I'm not in this. Like, this is about Stephen and his father, and I'm approaching this as like, I try to be the most ignorant audience member, where I'm like, I don't understand any of this. Like, what would I want to hear about that photograph? Why is it riveting? Why is it arresting to me? And if he can talk about it, which he can, I can cut that up, and hopefully the rest of the audience gets something out of it as well. So yeah, so it's such a broad question, but I always look at. I was thinking about framing from teaching intro. It's like that's all I ever think about is like what and he already did all the framing for me in a way. So.
Well, I mean, it's about storytelling, right? Anytime you're telling a story, you're choosing what's in that story. You're shaping, the way that you understand that story is framed literally by what's in and what's out. And I was struck by the ways that you took us through that narrative, Stephen, talking about the way that the pictures are positioned in the picture, in the story that it's telling about the space and the movement away from family and sort of a loss of sense of self. And I just want to kind of think about the spaces as well. For most of the time, you're in the nursing home with dad, right? The videography that we see there, you're in the nursing home. And frequently, our understanding of aging in the medical field is based on geriatric medicine because these are the doctors who have the most amount of contact with aging people. And so a lot of the data that we have about aging has a framing, right? And a lens that approaches it from a medical discourse of aging, death, dying, right? And so I want to ask you, Jeff, as you've begun to pivot your work to thinking about later life as another developmental stage, what's the reframing that you're thinking about in terms of later life as a developmental stage?
Yeah, I've thought about how we frame development for a long time. I first became interested in the 18 to 29-year-old age period that I call emerging adulthood. About 30 years ago, when I started studying people in their 20s, and they're so interesting. They have so much to say, and it's such a dramatic and important time of life. And at the time, and still now to a large extent, there's a lot of negative framing of how long it was taking people to grow up. Because people were taking longer to get a stable job, waiting later for marriage and parenthood, and all of that was portrayed as a kind of failure to launch, a reluctance to grow up. And I didn't see that at all when I started interviewing people and actually talked with them. So I proposed the idea of emerging adulthood partly to get people to reframe it and see it as actually really positive in some respects. People are going to make a lot better choice about what field of work to go in or what marriage partner to have or whether to have children if they wait until at least their late 20s or early 30s before they make those decisions, rather than about 20 as they did 50 years ago, as amazing as that seems. So now that I've been doing that research for a long time, I'm sort of looking for something else fresh to do, and partly as a consequence of the fact that I'm not an emerging adult anymore. I'm turning 65 this summer, so I've certainly been thinking a lot about how that's framed. Is 65 old anymore? I mean, it certainly used to be, and there are a lot more of us now who are fortunate to live in our 60s, 70s, and 80s than ever before. This is a really recent change. It's just really in the last century. I mean, in the 1930s, when the Social Security program was first established, you would get an old age pension beginning at age 65. At that time, most people didn't ever live to collect it. The median life expectancy was actually lower than 65. Now it's close to 80, and it's still rising. So a lot more people are living a lot longer than ever before. And we basically conquered infectious diseases. I mean, that may seem like a strange thing to say when we're in our third year of COVID, but it's actually a really good example of how we've conquered infectious diseases. This terrible, infectious, deadly disease spread around the world, and in a year or two, we'd come up with a vaccine that basically makes it possible for us to be here without masks on, at least mostly. It's good if you have a mask on. It's still a safe thing to do. But just in that short time, we conquered what in previous times we wouldn't have been able to do anything about. And so now very few people die of infectious diseases. Heart disease and cancer are the main sources of mortality. And so a lot of people, we have grandparents around in a way that no previous time did. We have parents around for longer than no previous time did. But along with that goes the greater likelihood and greater proportion of people who reach the state that Stephen's dad did. And it's hardly anybody ever lived to reach that state before the past century. So I think there's a lot of good reasons to frame older adulthood positively, because more people stay healthier for longer than ever before. And then there are things you can do. I mean, just what we know about diet and exercise and how those contribute to health as well as longevity. We've learned a lot about that in the last 50 years. But still, and even though there's a lot of reason for optimism, there is still that sort of tough reality that even if you've done all the right things, researchers on longevity say that there's basically a 3-part predictor to how long you'll live, and 1/3 of it is diet and exercise, and 1/3 of it is genetics, and 1/3 is who the hell knows. Nobody knows. It's just luck. It's random. Or maybe it's factors we don't know yet.
That's what I'm banking on.
Right, yeah. Who knows?
So we are living longer, but the reality is that more people will have the kind of experience that Stephen's father had, and the kind of experience that Stephen and his family had. I mean, I really urge you to watch the whole documentary, because to me, it is about his dad. It's really about Stephen and his family too. I mean, we didn't see enough of it, so he really got to introduce his brother and his sister and his mom. They become more part of it in the second half of the film, and it's horrifying in some ways, right? Because none of us wants to go out that way, right? If you look at research in psychology on fear of death, it's actually highest in the 20s. And as people get older, fear of death goes down. That really surprised me when I first learned it, because that's not how I feel about it. And it's a bit counterintuitive, right? Because you'd think the closer you get to dying, the more you'd fear it. That's not how it works. People fear death the most in their 20s, when they still feel like they have their life to live. They haven't had a chance to reach for those dreams that they have. They haven't had a chance to make those reality. But by the time people get to later life, they fear death less, because they feel like they've had their life, and they're less fearful of the end. But what people really fear in later life is that experience. That terrifies people more than death, because nobody wants
Deprived
to be in
of
that
your senior years.
state
That
of
you,
dependency, and becoming so dependent on others, and I was thinking of that famous line of Shakespeare's. It's in As You Like It, where he has this character, Jack, go through the 7 ages of man, and it begins with the mewling, puking infant, and then last scene of all that ends this strange, eventful history is second childlessness and mere oblivion, sans teeth, sans eyes, sans taste, sans everything. Sans everything. Wow. That would have made a great title, by the way. None of us want to end up sans everything, because as Stephen put it so well, I think actually this comes later, he no longer knew who he was by the end. He lost his identity. He lost his ability even to identify himself. You see that in that mirror scene.
yeah, that's of course you ended with that, which really cheered you up. So just very, very quick about aging is that I think, and most of you, I work on all kinds of projects and they go on for decades. And when my father died, it ended the project, and it ended me being in a nursing home. I actually miss being in the nursing home. I didn't think I'd say that in a million years. But to experience the end of life, the spirituality of it was mind-blowing. I looked forward to it week after week and year after year. I'm going to give you things that I think ended up on the editing room floor. And at one point when I was in the elevator to go see my father up to the second floor, I have this little mantra. I would see myself reflected in kind of the brushed aluminum, and I'd always say, you know, Dad, what are we going to do today? What kind of photo am I going to make? But one particular time I had a nurse near Diane, and Diane said to me, sharing the elevator, you know, your father's been here for 5 years. And I'm like, is that a good thing or is that a bad thing? And he's over there. It's just, she said, it's kind of a record. So it's like 1.2 or 3 years that the person is in a nursing home. And then I'm going to cry. She said to me, you know why he's here this long? Right, I'm looking at, for his son to make great art. So that's nothing, but I want to make you laugh. So, okay, this whole thing about growing older. My father-in-law lived to be 104. Okay, I just want to tell you that. Okay, I know this is breaking out of this, but I got to just tell you that the other side of this is also the big unknown. It really is.
Yeah.
So he's 104, and at 99, he gave up his driver's license because he said to me, I don't have the reflexes of a 98-year-old. I kid you not. And he also said that all I do is drive myself to the liquor store. You can do that. And so,
they
but
deliver
then,
now.
yeah, but the serious side of this, Jeffrey, is that when he was getting sick, he was having these spells where he'd pass out, and I would run down and see him in the hospital. And I would say to the doctors, you know, what's going on? And he says, we really don't know. We really don't have a lot of information about people living into those, you know, 100, 105 years old. And he's a living experiment. And that's bad. That's really, really, really bad. About the fact is that, you know, there's a good chance that a lot of us in this room are going to make that. So we don't want to hear that this is like the great unknown. So there needs to be a lot of changes here taking place. And I know I'm going to go ahead. You have a question?
Not at all. Not at all. Because we do want to get, you know, some engagement with the audience.
Yeah,
but
yeah.
there are a couple of threads that I'd love to kind of pick up here. One has to do with I loved what you all had you were starting to go down a road about kind of the communal aspects, right? The relationality, right? The relationships, right? The framing of the family and the relationship of the family and that. But also, you know, there's this notion of the paradox of identity making and identity loss, right? You know, so as you age, right, you fear death less because you've kind of had a lifetime to do stuff and to make a mark and to live meaningfully and well, and maybe that's the reason why, right? So another little bit of kind of, I want to inject a little bit of research in here as well about brain science, right? So, you know, after they finished mapping the human genome, they was like, let's do the brain. And so they've started trying to map the brain, and I don't know where they are with that right now, honestly, but they did this study on 90-year-olds, right? Which was hard to do, trying to see kind of, you know, what's going on with these 90-year-old folks and they were doing the science of the brain, looking at the plaque buildup on the brain that's supposed to contribute and be the kind of leading indicator of Alzheimer's.
Yeah.
And by the time they got to the end of the study, they knew less about the brain than when they started, because there were 90-year-old people who had the brain plaque that should have been in late stage Alzheimer's who didn't have it. They were good.
Wow.
And then there were others who had lesser amounts of brain plaque, and that all of the indicators biologically that should have indicated that they should have been kind of okay, but they had Alzheimer's. And so at the end of that, it's like, so what is that 33%, right? What is that last third, though? What the hell is this? What do we know? What's happening here? What is the factor? What's the thing, right? And it brings me back to, from my humanistic lens, this notion of perhaps identity making, meaning of one's life, and identity loss, right? I think about this a lot with respect to thinking about retirement, right? And what happens with people after they retire. And if there has been a loss of what's the word I'm looking for?
Engagement.
A loss of
something
engagement,
to
a loss of
look forward
community,
to,
a loss of
get up for every day.
Thank you, purpose. Can you all talk a little bit about that in terms of how you're thinking about it with aging from your respective perspectives?
Yeah, I mean, you know, I work on a really small local PBS show called Harvesting Rhode Island. I didn't think this was going to come up. And I've interviewed, or I've shot interviews and recorded interviews with a lot of farmers in the last few years, since 2014 or 15. And one of the things that's really common, especially in these in these like third or fourth or fifth generation you know, places, is that you know, somebody will sort of point out into a field and there'll be a tiny tractor moving along the horizon, and they'll say, that's my father, or that's my mother, and he's 98 years old, and the doctor says, whatever you're doing, just keep doing it, kind of like. There's no, and everyone is sort of confounded by this person still doing what they were doing in their young years, in their elder years. And also you know, my other kind of personal experience with this from filmmaking came from my first feature, which was called My Father's Vietnam, which came out in 2016. I'm not trying to plug. I just you know, one of the interviews for that film is with an elderly gentleman named Loring Bailey, and it was a person who was the father of one of my dad's friends who was killed in Vietnam in 1970. And this guy was in his mid 90s when I met him, or in his early 90s when I met him, and he became a friend of my family's and my wife's, and when I interviewed him, he remembered the date of his son's first day of school, and you know, so he's like the most lucid person. Like I say, like, he was more lucid than I am, and people laugh, but he was actually more lucid than I am. Like I don't even, I have no explanation for it. So you know, and it's just, and we, through just strange kind of grad school and jobs, we would be in Mystic or Stonington, Connecticut, like once a week, and we would visit him once a week, and he would, you know, make tea and, you know, just this guy's like in his 90s and finally passed away in 2010, or he passed away in 2009, and his wife passed away in 2010, I think, or vice versa. And but yeah, I mean, absolutely, this idea of keeping, you know, keeping active and doing what you love and all this stuff. But the thing is, Jeffrey, when I was listening to you talking about getting into these like really elder years, right? Actually, this issue with Stephen's father started when he was 60 years old.
Yeah,
like,
that
so
was one of the things about it that was quite chilling.
And for you to be 40, and I was older than you when I made the film than you were when you were taking care of your dad, and you were saying I'm 60 years old, and you know, if you speak to Stephen, it doesn't seem like he skips any beats. So you know, you do wonder, like, what can you possibly, like, what can we do to sort of prolong this lucidity and this kind of, like, you know, being with it and really enjoying ourselves, or trying, you know, being ambitious and feeling a sense of purpose.
Yeah.
You know, that's a big question, and it's not for
that does matter.
a filmmaking professor to.
The research on how people respond to retirement shows that they go in a lot of different directions, both in terms of how happy they are and how healthy they are, and those are correlated. And a lot of it does have to do with purpose, as Stephen said. Having something to really be engaged with. For some people, that means continuing to work part-time or going into volunteer work. Actually, quite a lot of people do that. For some people, it's taking care of grandchildren. For some people, it's, you know, taking care of the cat or the garden or something, you know, playing Wordle every day, I suppose. As long as you have something, it doesn't really matter what it is. That makes a big difference in how healthy and happy you are. But again, that's, you do have some control over it, but it's limited. That's the reality of it. And, you know, I think hopefully by the time we all get to that point, or maybe time some of you younger folks get to that point, there'll be really effective medications for reversing the kinds of things
we're hoping. We're counting the ways.
Documented, but but right now that's the reality. We do what we can, and for me it means appreciating every day, even at 64, almost 65. That's how I've responded to it. You know, waking up and feeling, gosh, I still feel good. I'm going to make the most of this day. And I didn't always think of that when I was younger. I do now.
So we want to open it up to the audience for any thoughts, comments, questions. Bob. Hi.
Yeah, I think I'm going back to Esther's initial framing question, but actually it's to ask two fairly unrelated questions. So one is, if people haven't seen it, I don't think it's revealing too much. So in terms of not framing the image, but the narrative, when I was watching the documentary the first time, I was like, who's filming him? Who's filming him? And so to me, it's interesting that we made it halfway through and we still don't know. So to me, I was wondering if narratologically, like one of the cruxes for you was that reveal, you know, of like, oh, there was somebody else with a camera watching the camera at that time. And then this is, as I say, pretty much unrelated, but I'm kind of picking up on Stephen's thoughts about like the framing of oneself as no longer a child. And it is true that my mother just passed away, and she passed away at 83. Now, I've often thought I would work till I was about 70, but I was sort of imagining like Queen of England living till I'm 100.
That's possible.
You know, and
We
so
all
there's-
are.
So
It
there's
helps to have a staff.
Yes. So yeah. So I mean, it's and also there are good genetics on the other side.
True.
But you know, it is interesting. You know, retirement with 10 years left seems like a different deal than retirement with 30 years left. And so I don't know if that comes up in your research. I'm asking you if I should retire sooner.
That's funny. So, should we, Bob, do you literal in the sense of like who's filming me? Is that what you meant? Yeah. So.
Yeah. Well, so Bob knows that it's Chris. It's not a spoiler.
My brother.
Yeah, this is Stephen's brother. In fact, on the subject of spoilers, and Stephen sort of said at a few points during this interview that you have to laugh at this stuff, or else you kind of drive yourself mad. And he said, you know, it's about in the interview. He said it's about Alzheimer's. It doesn't have a happy ending. I mean, you know, so you can't really spoil the film. I mean, you know, in that way. So it's a serious thing, but it's also sort of humorous. But we didn't. I actually had the pitch to Stephen about doing a film before I even knew that we had all this video. So getting all of a sudden this treasure trove of this video was just like euphoric. I mean, because you even saw the moment where he's photographing his mother and he says, "Chris, I'm going to have you participate," and it's like kind of like a little Easter egg in there. You know, you're not sure who's Chris and what is this, and then he introduces who his brother is and all this. But you know, but to have a moment where you hear the shutter of that big old camera click, and then on a video, and then I can go into the photograph, and like this weird kind of angle switch is just catnip for a filmmaker. I mean, I didn't even have to do anything. I'm just like, you know, and I like editing. That's my, you know, that's what I really like to do. In fact, this film won one award for editing, and that was the one I cared the most about. I didn't even like best short film. I was like, no, I want to win an editing award. I want somebody to like, you know, recognize what we did editing wise, because that was the thing I was the most proud of. But yeah, no. So as soon as I knew that we had that video. I knew that Chris had to be sort of part of the film, which he does become later in the narrative.
So I got to kick it. So everything I'm going to talk about makes you smile, makes me smile. So my brother couldn't go to the nursing home. It was just, he's the child, he was the baby in the family, and he wanted to remember Dad in better days. And I'm like, I had this video camera that I bought for a project that I didn't use, a movie camera. And I said, "Chris, you got to go see Dad." And he said, "I just can't do it." I said, "How about if I give you this video camera to film your brother, me, photographing Dad?" And he's like, "I can give this a try." And so I knew I was winning him over when he was waiting for me in the parking lot at the nursing home. And he'll say, "Take two." "What do you mean take two?" "Go back to the car and try walking out the other side." You can hear him doing that. And I realized I won him over. And he had enough courage through the camera, very much like I have courage through my camera, as a shield to some degree, a way to kind of a conduit to get to things, to walk in that nursing home and make those spectacular, all that footage that you've seen, or pieces of the footage you've seen. I have to tell you all that this guy made me feel so comfortable. And you all know I talk a mile a minute, and he slowed me down, and I'm trying to slow down here because I have 5 things going on in my head at once, and there's always a traffic jam in there. And what came first was the interview over a 2-day period. And Soren was brilliant. He just asked the right questions and the pauses. And yes, I was looking at a camera, but Soren, I knew was behind the camera. And so I love him dearly. And so that was easy to talk through the camera to get to him. I didn't know if I was telling the absolute truth in my memory. I'm like, because I'm wondering, I probably had Alzheimer's.
Psychologists, people almost never.
Yeah, right? And I thought at 38 it was over with.
There's only truth. There's no
yeah,
fact.
Yeah, at 38 it's over with. This is bull. So then when we got the, when he's over there, how many footage? I was like, oh God, I have hours of footage. My brother, are you kidding me? And so I made this delivery of this footage. And then when you're editing it in.
Well, it wasn't a delivery exactly. I had to meet him at a McDonald's on 146.
Yeah, with these huge hard drives. And so when you edit it in, it's like, oh my God, I was actually remembering this. That's pretty good. I guess I don't have Alzheimer's yet because of the fact that I was actually verbatim at times. Yeah. So that was a really remarkable moment. And the fact that you put this all together with the descriptions that took place. Oh, they're back there.
Christina.
Yeah, Christina.
Yeah.
We got to find out if Bob should retire.
Yeah, never retire. Don't.
We'll talk after.
Don't.
No, he should
Don't do it.
retire.
Don't do it.
I love this conversation, and I've been trying to formulate this question, and I don't really know how well it's going to come out, but it helped build off of some things that Bob said. So one of the things I was thinking about is that, Soren, your film, My Father's Vietnam, was very much about your relationship with your father, which I wondered how that affected how you approached this project. And then building on that, I was just wondering in general, if you all could maybe help us think about how we do think of aging because of how we see our parents, because all of you were sort of referring to that, like my father was this age and I'm now this age, or, Stephen, you were that age and now I'm this, we look at people and we see they were that age and now I'm this age, and how does that affect our sense of aging? So,
yeah, I mean, Stephen said something about having the camera as a defense mechanism, or kind of and Chris using the video camera as a defense mechanism. I use like bad humor as a defense mechanism, and so when we presented this, thank you for agreeing so quickly with that. So when we presented this film at Vermont College of Fine Arts, it was my master's thesis, and I think I had a similar question about My Father's Vietnam, and I said that this is the second in my Daddy Issues trilogy. And so like, I mean, my relationship with my dad is so different in a way, despite the fact that, if it wasn't for that relationship, and with my mother as well, I would never be a filmmaker. I mean, for sure, there's no doubt about it. But my dad didn't really know what I was doing. Like, he doesn't watch movies like this probably, and he watches a lot of movies, and he loves watching documentaries and stuff. But I think when I was collecting the footage for that film, I didn't know what I was doing either. So he would say, well, what is he doing? Through my mom usually. And I was like, I don't know, I'm just collecting footage. So, and I was lucky enough to be able to, have a little bit of skill as an editor, which came from, not filmmaking, came from music. But yeah, I mean, it definitely informed it. And the idea of this father being a mentor, or something that, again, this identity that Stephen forged his own identity in the shadow of, I think, absolutely. I think we're all sort of standing on the shoulders of giants, whether it's a parent, a mother, a father, or a mentor, as I consider Stephen to be one of mine. And the feeling is mutual, because he made me feel very welcome when I was a visiting lecturer here before my job was converted. So yeah, I mean, this is a big question, but these are important relationships to me. Absolutely. So yeah, hope that answered your question.
Christina, mine is acceptance. Like, my mother's 90 and knows way too much. And she remembers stuff that I don't even know if it's real, but she says it is. And so, at one time it used to irk me. We all know that because we're all kids. And now I just enjoy being with her. Of course, I'm photographing her. And so, our mother, everybody said, don't go see mother, you're going to give her COVID. Well, she gave us COVID. And then she wanted to bring us chicken soup a couple of months ago. Well, all the kids got sick seeing her on her 90th birthday. And the thing is, I just enjoy her. I go, and that took decades, because she's tough, and now I don't care. She can be as tough as she wants. She can criticize me as much as she wants, and I'm not living a proper life as an artist. I still get that, and I'm like, fine. I just love her, just to be around her, and I'm gonna hopefully be her someday, 90, I hope, and have that kind of sharpness. My father was devastating. You know, I'm going to bring up, most of you know Frank Armstrong, who right now has a big show at the Fitchburg Art Museum. And this is also about aging. And Frank came to this city because his wife took on a job when he was 62, 63. And he came to visit me to talk photography. He's a new guy in the block. So he's a new guy that comes in and wants to meet another photographer. And within an hour or two, I realized that he had a lot to offer still in his 60s, which I thought was old back then. And now I'm a few months younger than you, by the way. So, but by months. And I really wanted him to come to Clark. And I really wanted to get him an adjunct position here. He became my mentor. He's still my mentor. And for so many reasons. One is that I'm learning from him. I'm still a student. And the fact is that I want to be him someday. And he's like 25 years older. And so my little magic bullet is you should all have friends that are younger than you, your age, and much older. And that gets harder as we get older, but they're still out there. So I actually rotate. I visit a bunch of Professor Emeritus. I visit other friends of friends that are in their 90s. I bring them a bottle of wine. We get plastered. I hear all about great stories. They got 90 years worth of stuff to tell you. So, you know, and Matt, who's over there, we went to see an emeritus professor this morning, and we were good kids. And I said that to him as we left the Briarwood, which is a retirement community. And I looked at you, right? And I said, we were good kids today. We did good going to see this person for an hour. That keeps me young. That really, truly, truly keeps me young. I'm going to quote Frank Armstrong. So Frank, a number of years ago, his wife said to him, Frank, we're going to go on a cruise. It's 55 years and older cruise. I'm like, Frank, you're going to do this? Ellen wants to do this thing. So 2 weeks later, he comes back. I said, Frank, how'd it go? He said, effing old people. I'm like, wait, I'll never do this ever again. I'll never, ever hang out with old people. They talk about their hemorrhoids. They talk about their finances. And nobody ever, ever listens to you. And you know, I took that really profound. That was a really profound moment. Don't hang out with old people, right? And he's older than most of the people that are on that boat. Yeah. And so, you know, to have purpose, to value the people around you, and to have a vast scope of friends too. I have friends that have nothing, that no common interest. Most of my friends are a hell of a lot smarter than me, but by hanging around them, I get to look smart. So, and I think that's the magic bullet. I don't think it's a big, huge secret. I really don't.
Well, I want to say something about Stephen, which is this is a really good human being. What you see in this film, it is a film about decline. There's no getting around that. But it's also a film about courage. Yeah. And love. And it's about courage, both, I think, the kind of courage you show and your mom shows, you know, hanging in there. That's not an easy thing to do. I mean, if you've ever had to experience it, to visit somebody who is really no longer there. Yeah. As you put it, you're very honest about it. He's not there anymore. And yet Stephen goes to visit him, and his mom goes out of the love that they had for him and still have for them. And that not everybody can do that. I thought one of the most effective parts of the film actually was on his brother Chris, and how Chris just is not up to it. Yeah. And I don't know how I would respond. Neither of my parents had dementia. They both died for different causes. I'd like to think that I'd be as brave as Stephen and his mom, but I don't know. I think it'd be really, really tough. Yeah, yeah. And I think people respond in all sorts of ways that we can empathize with. Yeah. I mean, Chris's response to it, I think, is a very human response. Yeah. It's not because he doesn't love your dad anymore. It's maybe because he loved him so much.
He didn't want to let go of the image.
He can't stand to see him like that. And I think that's how some people feel.
Yeah. You know,
so you know, if you're thinking to yourself, oh God, this thing about Alzheimer's got to be really depressing. In the end, it's not. It's actually quite uplifting and consoling because of the love and the courage that it depicts. I mean, again, none of us wants to go out that way. Solves everything. But if you do, you'd like to think that the people who loved you the most and whom you loved the most would still come to visit. Yeah. even if you are no longer there?
I just want to, real quick to that, is I think thanks to your film and the book, is that the most asked question that I get from people is this. You know, my mother's in the nursing home, or my cousin, or my brother, my wife, my sister, whatever. And they'll say, I don't know how often to go and visit. And my response is, once a day might not be enough, but once a year might be one too many for some people. And the thing is, that's it. You have to search what's right for you, not for them, but for what's right for you to go and visit. And if you're dealing with dementia, dealing with somebody with dementia of some form, you got to live in the moment when you're there. You can't say, hey, let's go get chocolate chip cookies. That's over with. You know, or we're going to watch Casablanca again. That's over with. You got to live that exact moment with them and whatever they're reaching out for that time. And so that last year or two in the nursing home, it was something as simple as hearing a cardinal outside and then wheeling him out there and then tapping his ear and, you know, cardinal, the sounds, and he would kind of get it. Or just a lot of times it would be the sun on his face and touching him for the heat on his face. And I would become that also. You know, as an artist, you would do this. You become the subject. It's the best way, I think, to document. And but you know, I also, because he was in a nursing home that was the town he was born in and the town he died in, Marlborough. And so my high school friends were dealing with some of the same exact issues with their loved ones, their parents. And they would, Stephen, how you doing? You know, this big funny camera. Who is this guy, right, with this camera? And but they were tortured, and they were going to therapy, a lot of them, because they were not dealing. They were not, and I would say, back off, live the moment. I would become the therapist for them and sit down and talk to them for a long period of time to get them to understand that this is very important, that they're heroes to go. Same thing, whether it be once a day or once a month, but they're doing the thing, but they're learning also about themselves. Never forget that. You're learning about yourselves in situations like this. So we're
The man in the mirror.
The man in the mirror.
Yeah. Thank you, everyone. Please join us at the reception in Tilton Hall. Thank you to our esteemed colleagues here, Jeffrey Arnett, Stephen Dorado, Soren Sorensen. Thank you for our fabulous conversation.
That was good. Yeah.